So thank you, Sabrina and Hiroshi, for organizing this. Lots of people, great program. So thank you.
Very happy, grateful, and honored to be here. I was at both of the previous meetings of these conferences for primary lateral sclerosis, and the field has advanced greatly. Some central questions still exist. At the first conference, one of my heroes, Bud Rowland, this in Santa Cruz, asked me, he said, well, hereditary spastic paraplegia, that's a genetic condition often ascertained in families, not always, but often ascertained in families. And primary lateral sclerosis is typically ascertained as a sporadic event, non-familial. And Dr. Rowland asked me, he said, what if you found a gene mutation in a patient with primary lateral sclerosis? Would you now reclassify that as hereditary spastic paraplegia? He asked me that 20 years ago, and we're still trying to answer that question. And the answer is no. The person has whatever clinical syndrome they have. If they have a syndrome of primary lateral sclerosis, that's a clinical syndrome. And if it happens to be occasionally associated with an identified pathologic gene mutation, so be it. But that doesn't change the clinical diagnosis. And that question that Dr. Rowland asked 20 years ago is an important theme of what I'm going to say in the next few minutes. And I only have about 3 minutes left. Okay, so the first principle is that, and we're going to be talking now about how to distinguish hereditary spastic paraplegia from primary lateral sclerosis. And the first principle is that these are clinical terms. They're not pathologic terms. In modern practice, they're clinical terms. They're not genetic terms. They're clinical syndromes. Now, and they're very heterogeneous clinical syndromes. For example, Charcot-Marie-Tooth type 2, that's a clinical syndrome. Hereditary spastic paraplegia is a clinical syndrome, very diverse. Primary lateral sclerosis, also diverse, less, but still clinically and etiologically diverse. Now, second principle, gene mutations are not always identified in HSP. They're negative in at least 35%, sometimes more depending on the series. So a negative gene test in a person with suspected HSP does not exclude HSP. Conversely, gene mutations are occasionally, not very often, but occasionally identified in people that have the clinical syndrome of PLS. So, finding a mutation in a person that looks like they have primary lateral sclerosis does not reclassify the disorder. Now, third principle, the opposite of what I just said. The absence of a mutation does not mean it's not HSP, and the presence of mutation does not mean it's not PLS. These are clinical terms. There's a lot of similarities, obviously, clinical overlaps between these two. They're heterogeneous. They're genetically heterogeneous. How can I say that PLS is heterogeneous? Okay, let's be clear. There's childhood onset autosomal recessive PLS due to ALS2 mutation. And then there are children that look exactly like that don't have that mutation, meaning that autosomal recessive childhood onset PLS itself is genetically heterogeneous. That's two types. Then there's typical, whatever we consider typical PLS, or the most common form, slowly progressive leg spastic paraparesis, followed by upper extremity involvement, bulbar muscle involvement. Okay, that's the most common. Now, but then there are people with bulbar onset. Occasionally there are people with, very rare, I've seen at least one, with hemiparetic PLS. That's been described. So PLS itself is clinically heterogeneous. Then if we say genetically heterogeneous, well, 10% of people with PLS have gene mutations. Where are these gene mutations from? Sometimes they are found in ALS. For example, a C9orf mutation. Very common cause of ALS, sometimes manifests not as ALS, but as PLS. So we know that some people with PLS have C9orf, not many. Some people with PLS have C9 orphan mutations, some don't. So we know that PLS is at least etiologically heterogeneous, at least clinically heterogeneous. Sometimes, now HSP is 90 different disorders, 90 different genetic conditions. Many of these have other involvement beyond corticospinal tracts. So for example, many types of HSP have peripheral neuropathy. And on this chart, and I hope these slides will become available to everybody, neuropathy is not a feature of PLS. Now, neuropathy is not always associated with HSP, but if I saw neuropathy and I thought it was not due to any other condition, I would say that's not PLS because there is neuropathy. What about ataxia? Ataxia is not part of the PLS spectrum. It's not always part of HSP, but it's part, and so forth. So if we find these other complicating features, then it's not PLS. But these are not hard and fast because they're not present in every person with HSP. Now, last slide. These are clinical syndromes. They can sometimes be distinguished clinically if the complicating features in HSP are present, ataxia, neuropathy, so forth. But they may not be distinguished if they don't. If these are not present, you may not be able to tell the difference. Now, there are some features of PLS that are not present in HSP. And this is bulbar onset. Doesn't happen in HSP. That's an unusual presentation, I admit, but it does not happen in HSP. Now, also, the degree of lower motor neuron involvement. It's very common, late, and mild in PLS. And when it happens in HSP, it's usually more prominent and symmetric and insidiously progressive, like a distal motor neuropathy. But that kind of lower motor neuron involvement is not typical of PLS. Okay.
Okay.
Cognitive and behavioral features. So I just had a quick look at some of the literature that was out there, and I suppose it's quite interesting. There's a range. So obviously the top study, no cognitive or behavioral changes in PLS. And then there's a very precise group in Utrecht, and they felt that patients with PLS had cognitive dysfunction that was very similar to ALS. I suppose the question is this an ascertainment effect, or is it how people are being assessed? So we've also looked, and I suppose a lot of these series are quite small, but this is a series that we looked at of 21 PLS patients with John Hodges and Ineda Miyoshi. And I suppose what we find here on the left is that if you use the Addenbrooke's cognitive examination, there's reduction in PLS patients similar to ALS-FTD. And then similarly, when you look at, we used a MIND-B, which is a behavioral battery test that Ineda Miyoshi developed. And we found that the behavioural abnormalities weren't as prominent in PLS patients as compared to ALS-FTD. And that's, I suppose, the sort of summary, and that's very similar again to the Utrecht group who found those changes too, although they added that there were deficits in social cognition and theory of mind, which are in the PLS group, which is quite interesting. Now, in terms of the discussion with HSP, just looking at other ways to try and link the cognitive changes in PLS, and if you use TMS, transcranial magnetic stimulation, it's obviously a lot harder to activate the cortex. So if you find an inexcitable cortex, it's clearly a way to distinguish PLS from HSP. And the other changes that you see with PLS include an increase in the resting motor threshold, so that's corticospinal loss, and a reduction in SICI, which is inhibitory interneuronal function. And then looking across at the imaging data, and Peter is going to be discussing this more, but I think it's very interesting to look at his studies looking at language and speech and showing that there's a significant involvement in imaging on frontotemporal, subcortical, and cerebellar regions. So I think the basic summary of the cognitive changes is that they're very similar to ALS-FTD, but probably most similar to the behavioural variant of FTD. And the addition is social cognitive changes and theory of mind, with effects through executive functions, verbal fluency, and memory. And I suppose the message is that we probably need to have a standardized approach to assessing cognition in PLS patients. We probably need to combine across continents, and I think that's a great thing that Hiroshi's doing to try and bring us all together in a logical fashion. And I think we probably will see things that are slightly different from the PLS cognitive changes that will underlie the longer survival. And I think unless we do this standardization, it's going to be very hard at an international clinical trials level. So that's it. Thanks, Leonard.
Yeah, great.
So I'm Matt Harms, and I'm from Columbia University, and I was hoping to add to the left-hand side of this slide and include the genetic analysis of all of the PLS natural history study participants, but unfortunately they're still on the sequencer, should be coming off shortly, and so next time I'll be able to present on that. But what I will tell you about today are our efforts in the Columbia Precision Medicine Initiative to aggregate a PLS cohort from the studies that are illustrated here. So of our 9,100 motor neuron disease samples, 172 have diagnoses of PLS. 79 of these, mostly coming from studies led by Dr. Mitsumoto, have clear-cut criteria by which these were assessed, and the others from the metadata were diagnosed at their tertiary care centers with PLS. The criteria aren't more specific than that. In this cohort, 59% are male. The mean age at onset is 56 years, and for those where we have a site of onset, not surprisingly, it's spinal and lower extremity, followed by upper extremity, and then the least common is bulbar. There are a handful of individuals with a more generalized presentation. The first thing that we undertook, as have several groups represented in this room since the last meeting, a known gene analysis of this particular cohort. So we analyzed 447 genes distributed across these multiple different neurodegenerative conditions that can have overlap, and consistent with previous findings that we presented in 2019, but then also in the previous publications that I just referenced, we have found a handful of monogenic cases in this PLS cohort. The most common were people who are autosomal recessive carriers of SPG7 mutations. These are likely pathogenic or pathogenic known mutations. We found 2 carriers of full-length expansions in the C9orf72 gene, 1 spast loss of function carrier. We were surprised in an outside cohort that contributed to find a D91A carrier of SOD1, and then there's 1 compound heterozygous patient who has a Niemann-Pick-like phenotype. We did find many variants of uncertain significance. When you look in this many genes, that's not quite surprising, and so it could be that the monogenic explanation rate is actually higher than the 5%, what I would call diagnostic rate that we identified here. But this number is very close to, for example, a similar size cohort from Utrecht. So we've also, now having amassed this many individuals, decided to try to undertake a very dramatically underpowered burden test or collapsing based test to see if we could identify any novel genes. We compared the 166 PLS patients with adequate whole genome sequencing to around 18,000 ancestry matched controls. We ran several genetic models that I won't go into the details for an effort of time. And here shown is the QQ plot of our burden test. And you'll appreciate that there in the very far upper right-hand corner, trending well away from the line of equipoise, is the gene ANTXR2, or the anthrax receptor number 2. Genome-wide significant, exome-wide, or experiment-wide significant by our metrics, with an odds ratio of 174, which is quite surprising. And if you look at the individual loss of function mutations that were identified in PLS, you see that we really only found 3 PLS patients carrying these loss of function mutations. But out of those 18,000 controls, we only found 2 non-PLS patients who carried similar mutations. You'll appreciate some of these, shown in the far right, are quite common in NOMAD. These are in fact alleles that, when recessively inherited, cause the disease that this gene is actually known for, which is infantile systemic hyalinosis, which is a disorder of skin and cartilage and connective tissue, but is usually fatal because of progressive contractures that infants develop. So this is, we believe, is a candidate gene for being related to PLS, but it could still, given the small numbers, be an artifact or some population stratification that we haven't yet appreciated. This gene is in the right place at the right time. It's highly expressed in brain, both in astrocytes and neurons, in the cortex and in the spinal cord, and it's a receptor for the anthrax toxin. It's a transmembrane protein with an extracellular domain linked to the extracellular matrix. And so it would be in a very different pathway than we've looked at or considered for any other motor neuron disease. So I will stop there. I think it's just a candidate at this point.
Thank you, Hiroshi, for inviting me and allowing me to contribute to this meeting. And I understood my contribution as a clinical one, if I see the entire program. And if you want to comment clinically, you have to see the anatomy of a disease. And in this case, it is quite easy, because the first one who described HSP and something like, you will judge yourself, PLS was Strümpel about 125 years ago. He was a professor of neurology at the University of Leipzig then. The first issue is, I think, well known. He was a friend of Charcot, and he liked his clinical anatomical method. He related clinical findings to anatomy. And it was clear he had two families, the Gaume brothers and the Polster family, 8 patients, which he accompanied during their disease for 20 years, and then did autopsies, and he was clear this was an entity clinically, pure spastic spinal paralysis, and anatomically a primary symmetrical nucleodistal degeneration of the corticospinal tract. You all know that to a minor degree in this disease, the gracile tract is involved and also the spinal cerebellar tract, and they degenerate in a length-dependent fashion. This was all described by Strümpel at that time, and of course he suspected a genetic disease. What about PLS? He did not use the term PLS. He said, I have seen something which is in between ALS and HSP, but resembles more Charcot's disease. I will tell you about the clinical causes of these patients, because before I get to the substance of my talk. The first patient was patient Riegel. She was 64 years old. Strümpel, at her lifetime, gave her the diagnosis Parkinson's disease, paralysis agitans without tremor. But it was a rather fast disease. It was asymmetric rigidity, what he saw. He had increased reflexes and some motor inhibition. You see it in her face on this photo. When he did the autopsy, he was very surprised. He saw ALS, in principle Charcot's disease, degeneration of the pyramidal pathway, degeneration of the anterior horn cells, of the hypoglossal nucleus, and neurogenic muscle atrophy. And he commented, I'm ashamed, I never thought of ALS at lifetime. He didn't see any atrophy. He saw a second patient in which he did the diagnosis of amyotrophic lateral sclerosis, and he found anatomically or pathologically exactly the same as he found in Mrs. Riegel, and the clinical difference was only that in the end of the disease, the patient presented with atrophy and paresis. He didn't use the term primary lateral sclerosis, but he saw these patients as an entity of itself, very close to Charcot's disease. He did not go further. So what does this tell us about the validation of our criteria to test for sensitivity and specificity? Of course, if you want to test criteria, you need the diagnostic criteria. I wrote them down here, but I have doubts for the validation process of criterion number 2. symptoms of progressive upper motor neuron dysfunction for at least 2 years. It's okay, we can discuss it, but in our series, which we just published in JNNP, 107 patients, we had 33, it was a cohort study, not a study before these criteria. We could not have given this diagnosis because we diagnosed it after 1 year. So I suggest we think about to increase the sensitivity of an earlier time point of 2 years, just for the study, nothing else. I don't want to change the criteria. So we need a longitudinal study, it's clear, a yearly examination, and of course a diagnostic re-evaluation if we find another diagnosis to test the specificity. We also need to document the time of onset of lower motor neuron deficits, clinically and EMG, and I think we should document, and that has rarely been done, at least to my knowledge, the upper motor neuron signs and their relation, reflexes, affect, Hoffman signs, Babinski sign, and related to another well-accepted upper motor neuron sign, increased muscle tone. May it be spasticity or rigidity, like Strümpel said. I'm a little bit on the side of Strümpel, I have to say. But let's see. Bladder instability is also perhaps related to the upper motor neuron signs. And of course, we have to document the onset, symmetry, HSP versus PLS, spreading pattern, pattern of muscles affected. So the conclusions. First, we have to ask ourselves the question whether for such a study, we need the diagnostic criteria for the inclusion criteria. I have doubts. Perhaps we can include patients earlier, after 1 year. I think we should prepare for symptomatic therapy as well, as Strümpel already said. These patients suffer from the increased muscle tone, bladder dysfunction, and so on, and that's it.
Well done, thank you.
Well, thank you. Thank you, Hiroshi, for the invitation. I'm Eric Sorenson. I'm from Mayo, Rochester. And I was asked by Hiroshi to discuss the role of electromyography in the diagnosis of PLS. And so, obviously, PLS is thought to be a relatively pure upper motor neuron syndrome, but it's widely recognized and accepted that there's some element of lower motor neuron involvement. And it's generally accepted to allow some findings on the EMG to be inclusive of the diagnosis of EMG. And while I say it's controversial, maybe that's too strong of a word, but there's no strong consensus on what this represents or what this means, minimal findings on EMG. And this has led for some people to call for an intermediate diagnosis level of probable PLS for those who have changes on the EMG, and are sort of in the years between 2 and 4 years of symptomatic duration before they've really sort of clinically declared themselves in terms of their diagnosis. And it was a few years ago now when Hiroshi was putting together the natural history PLS study that he talked to Darrow and I about being co-chairs on the EMG committee with the goal of really codifying what this means, to what kind of what changes should be allowed in a patient who's going to be enrolled in a PLS study. And it was about that time, this was relatively soon after the Gold Coast criteria for ALS had been published. And it seemed to us that that was a relatively low bar for the diagnosis of ALS. And so we decided, or we discussed it, and thought that we could sort of take the inverse of this as allowing for the diagnosis of PLS, or what would be allowed and included for a PLS study. And I think probably everybody's familiar with the Gold Coast criteria for ALS. And so I did put those on the slide here to summarize it. It's pretty straightforward. It requires the presence of neurogenic motor unit potential changes in the sense of large or high amplitude, long duration motor unit potentials with the presence of either fasciculations or fibrillation potentials in multiple myotomes within a region. And so this sounds pretty straightforward. And there's a lot of discussion on the committee. Some of the committee members are here. During the discussion period, I would welcome your input on this as well. But in accepting this as allowing for the diagnosis of PLS, It does take there's certain extenuating situations which we had to consider. One, for example, is if you took this approach, then if you had chronic motor potential changes in a fairly widespread distribution, but only had fibrillations or fasciculations in a single myotome in any one limb, that would qualify. Otherwise, if there were fibrillations or fasciculation potentials in multiple myotomes or more widespread, but this was not associated with chronic motor unit potential changes, that would qualify. Or the scenario where you had in multiple limbs motor unit potential changes with or without fibrillation and fasciculation potentials, that would qualify. And there was discussion on the committee whether that was too liberal to allow that to be included in the study. I think ultimately, after a lot of discussion, we allowed these patients to be included in the study for the sake of inclusivity and to see what happens to these patients. Do these patients go on to have an ALS phenotype or do they retain a PLS phenotype? And these were the anticipated issues that we had when the committee met to establish what the ground rules were going to be for the EMG changes. There were some other unanticipated issues that we ran into. One of those was how we would deal with equivocal changes. So, for example, an EMG report might say rare fasciculation in a muscle, or might say occasional positive wave in a muscle, or it might say slight reduced recruitment, or it might say, or some reports would have the grading scale plus minus. And so we had to decide what the intent of that report was. And I'll just tell you that is not easy when you have to make that decision. You have to make that judgment. Overall, at the end of the day, I think the committee decided that unless it was unequivocally positive, that we did not change the classification. You will see, Darrow's going to give the talk later about how this performed in the course of the study. But you will see there was disagreement between how the centers might have classified the patient, how our committee might have classified the patient. And even within our committee, as we were reviewing them, there were disagreements about whether this patient should be considered an ALS case or should be a PLS case. But ultimately, I think we erred on the side of being inclusive and allowed those patients to be enrolled. And am I out of time?
Yep.
All right, I'm out of slides.
Thank you. So I'm Lauren Elman. I was asked to talk about the PLS NHS diagnostic criteria validation. So we did actually do a study similar to what Dr. Ludolph was talking about to try to validate our new diagnostic criteria through a natural history study. So I'm going to tell you a little bit about how that worked, not all the details though. So at data cut, so just a little bit about the study. Patients with early or possible PLS were enrolled, which is less than 2 years of symptoms, so not really qualifying at all for PLS, but maybe PLS. Patients with probable PLS, which is 2 to less than 4 years of symptoms, and patients with 4 to 15 years of symptoms, and you can see how many patients were available at data cut. So by which I mean patients who had a 12-month EMG. Dr. Heitzman and Dr. Sorenson were head of the EMG committee, as you just heard. So they evaluated the entry EMG to make sure they were eligible for the study, and an EMG at 12 months to see if they still qualified as PLS, as you just heard. Most notably, there was a discrepancy between whether the clinicians thought that patients still had PLS at 12 months and whether the EMG committee still thought the patients had PLS at 12 months. Specifically, clinicians thought that there were 9 out of 59 diagnosis changes from PLS to ALS at 12 months, and the EMG committee thought there were 5 out of 59 diagnosis changes at 12 months. The rates of conversion for the clinicians were 1 out of 4 early PLS, and the numbers in parentheses, by the way, are how long the individual patients had their clinical syndrome for at the time of diagnosis change. So for the early patient, it was 3.6 years, just to give you an example, and I won't read out those numbers because you can see them for yourselves, and I am being timed. There were 5 out of 23 patients with probable PLS, at enrollment whose diagnosis changed by their 12-month EMG, and 3 out of 32 definite PLS. That's what I found surprising, by the way. That represented 15.3% of patients. As far as the EMG committee was concerned, and they were very strict, as you heard, with their criteria, it was 2 out of 23 probable, but again, most surprisingly for me, it was the same 3 out of 32. By the way, there were no differences, so the 5 that the EMG committee thought were diagnosis changed were from the 9 that the clinical committee thought. So there was no specific discrepancy there, and that represented 8.5% of patients. Now, I'm going to say something a little bit provocative because we're supposed to be having a conversation. So I just want you to think about, when we're thinking about clinical trials and such, how good do we feel about this? Is this great? Did we do a great job here or not? And I also want to confess that I thought I would be able to calculate the sensitivity and specificity of these diagnostic criteria, but there was a fatal flaw in my thinking, which you've probably already come to, which is that since this was a prospectively enrolled study only of people that we thought had PLS, that's completely impossible, because when you try to make that 4x4 box, you don't have the right denominator. And we'd have to go back and see how many people were diagnosed with ALS at all those clinics that were enrolling during that time to figure that out. So that's why you do not see sensitivity and specificity here, not because I didn't think of it, but because it's an impossible statistic to calculate based on the data that we collected. So that was a missed opportunity, I think. But and anyway, this is my last slide. I am responsible for the pent-up or motor neuron score, and I just want to tell you that in the PLS population compared to the people who actually had upper motor neuron onset ALS, there is no difference in the upper motor neuron burden, in the total upper motor neuron burden or by segment. But for those of us who do make our lives as clinicians, it is interesting and reassuring to know that it is true that people with PLS have more upper motor neuron disease in their lumbosacral region than in their cervical region, and we can show this statistically. Not important, but interesting and validating for us clinicians. Thank you, that's all I have to say.
Okay, thanks very much. So our register has been running for 30 years. So we've looked at our register. Rob McFarlane, who's here with us, has done the analysis for me. We have 94 cases with PLS. We used the criteria of more than 4 years with the pure upper motor neuron science. So we had 94 cases over 30 years, 51 female, 43 male. 10%, you can see the onset there, mostly spinal, 10% bulbar. The age of onset is, there's difference between males and females. It's in the late 50s. The incidence is 0.7 per 100,000 standardized the Irish population, and it's, that's by age cohort. What's interesting, though, is that we have 40 patients in that cohort that are still alive. And so this is based on their life expectancy from birth, from their birth cohort. So the oldest patient was born in 1899, or 1907, I think it was. So the life expectancy in PLS is similar to that of the general population from the same birth cohort. So these people don't convert to ALS, the cohort that we're looking at. They continue with an upper motor neuron sign, but the signs I mentioned. They have some cognitive change. This is our data from using ECAS and also looking at behavioural change using the Bowman Behavioural Inventory. And we're looking at people before they had their PLS diagnosis based on caregivers and after. And they have mild behavioural change, not great behavioural change, but they do have cognitive change, which is both ALS specific and ALS non-specific. Of those 93, 22 required NIV. Very, very few, only one patient required a gastroscopy, and he didn't want it, he took it out afterwards. Most of the patients are on baclofen and tizanidine. They get Botox for their spasticity. Some of them come on Cinemet, but as Albert said, the Cinemet doesn't work in the longer term. Peter's going to talk about the neuroimaging, but there are useful advanced neurophysiologic tools that you can use. For example, cortical muscular coherence, and we've got a paper where we showed that that's different between PLS and ALS. There's much more spread of the cortical muscular coherence in PLS patients compared to ALS patients. Thank you.
Perfect. Well, thanks, Orla. That was a tour de force, beautifully on time. Our next presentation is Osamu Kano, who's going to tell us about the Japanese registry. Thanks, Osamu.
Yes, thank you. Hello, everyone. My name is Osamu Kano from Tohoku University, Tokyo. Today I'm going to talk about the Japanese LS registry system JACARS, which includes the PLS. We survey the natural history of the LS and including the PLS. And we also check the blood test at the initial visit of the enrollment. And until last year, more than 2,000 LS patients were included in the registry system. And the LS patients in the registry were classified by motor phenotypes in the earliest phase of disease. So most of LS patients change healthcare facilities during the disease courses. And the first the patient visits our hospital first, but after that, some patients change the hospital to the regional hospital and or home visit physicians. So we built a telephone service system, and we made the follow chart of LSFRSR for the telephone survey, and we also make sure the reliability of the telephone survey of LSFRSR. And this is the summary of the registration system. First, the physician checks the medical exam and completes the CRF, including the LSFRSR, and the physician reports the CRF once a year. And after the patient changes the healthcare facility, telephone operator calls the patient or their caregivers and conduct a survey every 3 months. And the telephone operator asks everything from the patient about the respiratory equipment and the nutrition and also LSFRSR score. And this is the data, the data of the PLS type. The definition is, sorry, the definition is only upper motor signs over 3 years after onset. And the mean age at onset is around 55 years old, and the median survival time is more than 10 years, and 5-year survival rate is 77.8%. So if the PLS clinical trials is realized, we can inform through the JACARS homepage website. Thank you.
Thank you, Osamu. Okay, we might get Leonard now to give us the NCALS experience.
Yeah. So the title of my presentation is the NCALS PLS registry. Well, the short version of my presentation is that we do not have an NCALS registry for PLS yet, but it's under construction, led by Orla. I was expecting her to mention it in her presentation. Yeah, precision ALS. It's a. Do you want to explain? No, it's a European database, not only for cross-sectional data, but it's actually meant for follow-up data, and I think that's very important in PLS also. Yeah. So it's under construction, and I asked around. Everyone has his individual database in Europe. And in total, we have about 1,000 patients in Europe in follow-up. So just a few more slides. So this is, we have 3 population-based studies in Europe. One in Ireland, as you just heard from Orla. Another one is in Adriano's Chios site in Piemonte. Very good wine as well. And this is the data, and I think it looks very similar to the IRIS database of the clinical features of the patient, the Italian patient. So that's very, very similar. We have also a database, so that's the third population-based database that we have started. We started in 2006. And we have, so we did a short study. Actually, Michael Van Es did that in our group. So we had 83 patients with probable PLS according to the latest Turner criteria, who had a disease duration from 2 to 4 years, and 359 patients with definite PLS, so disease duration of more than 4 years. But as I already mentioned before, 72% of the patients with probable PLS progressed to ALS, and only 6% in the patients with definite ALS. So in our opinion, you can only, it's best to diagnose a patient with PLS after at least 4 years, and that's difficult. And this is actually the graph showing that actually also in year 5 and 6, and there are more patients converting to ALS, but most patients with probable PLS convert. So most patients with an upper motor neuron syndrome convert within 4 years. Then we also did a follow-up study. We submitted that for publication. So if you're a reviewer, be nice to us. It's 87. I'm not going to discuss the whole thing because I only have a few minutes. But it's just to say that the diagnosis is still uncertain up to 4 years. And but even after that, the diagnosis can change, as shown in this slide. It's a 13-year follow-up, so this is different groups. I won't explain it in detail. This is according to the Turner criteria. But in our opinion, and we're Dutch, so we always have another opinion, which is usually good. But so this, I think it's better to, and that's actually also according to John Fink's, that what he just said, that if you have bulbar symptoms, you cannot have HSP. So if you change it around, you can only diagnose PLS if you have bulbar symptoms. So that makes the diagnosis definite if you have bulbar symptoms. And so it's less clear if you just have lower limb and upper limb, but still, if the duration is shorter than 4 years, many change to PLS. So follow-up studies are important. It will change the diagnosis. Michael also did some autopsies in 5 patients, and it's surprising what you see in terms of other pathological features from other neurodegenerative diseases. Maybe you will have time to explain that later. Okay, thank you.
So Hiroshi-san asked me to talk more about potential study design and current study designs in PLS or other ultra-rare variations, I would say. So first of all, disclaimer, under no circumstances I'm suggesting to compare people living with PLS to fishes, but rather our processes sometimes remind me of fishing exercise. So if you're fishing with a rod, so sometimes it may be a time-spending activity rather than result-bringing activities. So Hiroshi-san runs a very well-established PLS natural history study where we have 32 sites and we have recruited 76 people with PLS, living with PLS. So it took us a significant amount of time to activate the sites, to go through the ARBs, to go through the contracts. And then 7 sites have 0 patients recruited. So it was a nice, time-spending exercise. Again, this is by design, so it's no one's fault. It's a traditional design, looking for ultra-rare diseases. So another exercise or another design is more of a trawler, where you're using nets of different sizes. And I would compare our natural MND-ALS natural history consortium exercise, where we have 11 sites with 2,800 or so people with MNDs, and out of them, 115 have PLS. So again, we're asking everyone who consented to this from the site investigators who agreed to participate in the consortium to approach everyone in their clinics, kind of very much trawler net approach. So there are better methods, right? So if some of you did deep sea fishing, I did it once. So there was a boat that says, here's a radar, and poor fishes have nothing, there is no way out, right? So the worm, an artificial worm, is being brought to their mouth to be swallowed. So they know everything where each individual fish in the ocean is. So it's a great way, but how do you achieve this? So one of the ways is very simple. You find these people living with PLS first, you activate them, or rather activate the sites around where they are, and then you consent, collect, capture, share. So as a continuation of this, of Hiroshi-san's Columbia University Natural History study, now we have an extension amendment to this protocol where all these participants will be moved to an online platform, people outcomes platform, we call it NeuroPro, and then we will be collecting information from these participants online, and then if some of the sites decide to stay in the study, we may continue collecting this information at the sites as well. So another way of doing this, even more modern approach, is to extend this approach that I just described and say, hey, let's discover consent online, capture information online, and make sure that we share this information with anyone who wants to be to analyze this data. So we're offering this platform as well. And then there is another alternative complementary approach. Basically, anyone, any site in the world who happen to have people living with ALS in their clinic, download the protocol, download the consent language that makes sure that you will be sharing information, that you will be generating unique identifier, that you will be telling patients what you plan to do with this, with his or her data. Then you consent, collect, capture, and repeat it annually in case of PLS. And everything is provided for free or free of charge. So it's a minor, really minor, probably we figured it's 5 to 10% FTE a year per site just to handle this information. And then you can join PLS consortium and you can enjoy your activity as part of this active community. So in other words, to re-emphasize traditional approach, activate sites, wait for potential participants to walk in. Decentralized approach, find participants first and then activate the sites. Hybrid approach, do both of this. So, you know, enjoy everyone who walks into a clinic and consent them. Find anyone online and bring them, confirm the diagnosis certainly, but bring them in. And then activate additional sites if required under this. And there are a couple of resources that are available. First, protocol. Anyone can download natural history protocol online. Consent form has a very specific language. So some of you here helped to develop this language, including Matt Harms here. So basically it was a breakthrough for his study in GTAC, where we created an Uber consent language that says any information previously collected on me could be used in this study. So this is an Uber language, Uber consent. And another thing, and there are tools available. Thank you.
Thanks, Alex. So now we're going to hear a U.S. perspective from Paul Meda.
Thank you, Hiroshi. My name is Paul Meda. I'm the PI of the National ALS Registry. And so obviously we're ALS, we're not PLS, but Sabrina and Hiroshi came to me actually this past year about adding PLS to the registry. So they had a letter which came to our director and we responded accordingly. So just a very quick background about what we do. We are the largest, probably ALS research registry in the entire country, if not the world. We have over 20,000 self-registered patients in the US alone. Our main cores are looking at the incidence prevalence of ALS, demographics of disease, and more importantly, looking at the risk factors and possible etiologies. When Congress enacted this act back in 2008, it was quite broad. And one of the things they said was looking at MNDs, ALS was the primary focus, but since PLS can certainly be confused with or lead to or be misdiagnosed with ALS, we have the authority within the actual act itself, which is actually a law, which makes us, pursuant to that, to actually look at PLS as well. The issues with PLS right now is what we explained to Hiroshi and to Sabrina is the fact that the lack of resources. So ALS was pushed by the ALS community in general to make sure ALS was looked at and having their own registry. So PLS certainly could be added to the ALS registry as a silo or a separate registry by itself. It would require some effort on the PLS community to make it happen. We have the infrastructure to make it happen. Like I said, we have over 18 risk factor surveys, 115,000 collected surveys from ALS patients. So it's a pretty robust, active system we have. So for us to go ahead and make this happen, like I said, this kind of spells it out exactly what we could do to go ahead and serve the PLS community out there to go ahead and make that happen. Like I said, we have the resources, we have the expertise to go ahead and add PLS to the registry. It's just a matter of having the public support to make that happen and so forth. But that's what my talk is about right there. So the fact that we, as the National ALS Registry, only do ALS at this time, but PLS could be added to the National ALS Registry. Thank you.
So we're doing perfect timing, and now we've got Hiroshi bring it all together in terms of harmonization of all of the registry data.
Well, thank you very much. I'm talking about PLS natural history study. The study was funded by Spastic Paraplegia Foundation, ALS Association, Mitsubishi Tanabe Pharma of America, and of course, Mr. David Marin and the family. So it started a long time ago, I think 2020s, and structured with steering committee, EMG committee, and diagnostic validation committee. This was a distribution of centers, and also funded by Neurobank and MDA wings. The study was actually methodology and protocol was published with the kindness of Orla Hardiman, editor of ALS FTD journal, so everything available. The characteristic of these things is actually mostly telephone, and baseline 3 months and 6 months, 9 months, 12 months, 24 months. And yellow signs are all in-person visit, and white is telephone visit. And we aimed 50 early, means actually 2 to 4, and probable 2 to 4 ALS. Early is from onset to 24, and 50 is definitely PLS. Why we chose this early PLS is always I believe if you treat anything, early is better. I really didn't care whether we make the wrong diagnosis, right diagnosis. We need to study. That was kind of based on these studies. So we had case already presented before. Early cases, 5 cases, and probably 25, and definitely 42. There's some numbers different, and you can see the age and sex ratio, and duration of time you can see. So study occurred during COVID pandemic, which impaired our recruitment, and the patient cannot come to the centers. Also, difficult recruitment confirmed again PLS is exceedingly rare disease. And nevertheless, the PLS natural history study provide novel result on long-term PLSFRS and functional scales and quantitative outcomes, which you're going to hear later. And also PLS natural history studies also offers extensive DNA and biomarker data. Again, Matt Harms already bruited. And PLS natural history study is first and only study looking at the long-term natural history, which I said is wrong because other people are looking at long-term, but we are looking at not just the 24 months, but also looking for 4 and beyond. And but for future clinical trials, which never done PLS, we are convinced that multinational, multi-continental study arrangement is essential because, see, United States is so big, we had struggled and collected this kind of case. We have to work together, European, Australian, Asian, and all those people together, and we have to get the proper numbers. We hear how many patients we need if we do clinical trials. So that's it. Thank you very much.
Real pleasure to introduce Peter Bede at the cutting edge of neuroimaging, and Peter's contributed probably more than anyone else to understanding PLS, and is going to talk through all the work he's been doing and where we are and where we might go. Thanks, Peter.
Martin, thanks so much. Martin, you're very kind. Thanks so much for this introduction. And Hiroshi, thanks ever so much for having me here today. I won't be too long. I want to share you my experience looking at PLS over the years. And if I had only one slide to show, I would be showing this one, right? So this is a summary slide of what is affected, what's happening to the brain in PLS. So these are patients, these are 50 patients with PLS who had the disease for about 5 years at that point, and that's what PLS does to the brain. So anything that's green, that's a statistical map of which white matter regions are affected. And if you can see, the descending corticospinal tracts degenerate, the corpus callosum in the middle degenerates, and all the white matter subjacent to the motor cortices bilaterally degenerates. So that's a summary map of what PLS does to the brain. But if you look at this sagittally or sideways, there are a few things that are somewhat unexpected. What you see is the changes outside what we normally think of as PLS. I always conceptualize PLS as something that's selectively affecting the pyramidal tracts and the descending motor neurons. But it seems that the cerebellum is affected, and that's a very consistent signal. If you look carefully, there's temporal lobe involvement. And, but that would be the signature, the white matter signature of PLS sagittally. So anything that's green is affected. If you look at the brainstem is affected. It's not surprising. You can capture that. We have various ways of looking at brainstem atrophy. So these are called vertex analyses, and what we see, anything is orange is atrophic. Okay, so these are statistics corrected for age and sex and other sort of demographic factors comparing patients with PLS to age-matched controls. If I look at the volumes of various brainstem regions, what sort of surprised me is many of these are more affected in PLS than in ALS, right? So once I stopped doing comparisons between healthy controls and PLS patients, I introduced disease controls. That's where the story becomes more interesting. But so descending corticospinal tracts are affected, corpus callosum is heavily affected, brainstem is affected. If I follow further down, that's the decussation of the pyramidal tract, which we can visualize very well now using tractography or diffusion imaging, NODI. There's sort of methods now that we can use to capture the anatomy and not only describe it, but measure the integrity of those fibers. So, our example, I can pick relevant fibers that's relevant to the cohort you have at hand, that's relevant to the clinical question you may have or your academic hypothesis, and you can measure those, you can dissect those specific tracts, measure their integrity, and once you do that, you can track it over time as well. So these are more of the same what diffusion imaging can offer. This is spinal cord imaging, something that I'm hugely interested in, and you can sort of see the H-shape outline of the gray matter in the middle, and all those blue bundles are the various white matter tracts, posterior columns, lateral columns, which are relevant. And again, it's all quantitative. You can visualize it like this. It's a bit hazy, it's diffusion data, but you can measure how badly those tracts are affected. And that, you can use that in diagnostic protocols if you wish. That's just another way of looking at it, I suppose from different views, sagittally, axially, coronally, and using various metrics, you can highlight the affected regions in a group of patients or in a single patient. And I think that's what's relevant. For years, we've been doing studies comparing a number of PLS patients and comparing them to controls, and I think we need to stop doing that. I think the money is making sense of data from a single individual, because that's my clinical dilemma. If I see a patient, I'm not interested in the general trajectory of PLS. I want to know, is this patient going to develop ALS eventually? Is the imaging signature consistent with what I normally see with PLS? So that's another slide I wanted to share with you. This is looking at cortical changes. So up to now I was showing white matter alterations. And that sort of fascinated me when I first got these results, because what you see, while the motor cortex, the primary motor cortex, presensory gyrus is heavily affected, but you see ample degeneration in extramotor regions, right? So maybe starting from the bottom, you see dorsolateral prefrontal cortex affected. Michael Finesse and the previous, Matthew Kiernan was talking about behavioral and executive dysfunction and language dysfunction. So that's the substrate of it. So there's a lot of frontotemporal pathology, cortical thinning, density loss, atrophy in extramotor regions. And we can capture that very, very easily using very simple, transparent, reproducible metrics and techniques. Let it be cortical thickness analysis, cortical thickness mapping, VBM. It's all very consistent, that signature that PLS picks up frontal, temporal, anterior cingulate is affected. You can see it sort of on the third row down, which is obviously vital in many networks, default mode networks. You can see insular changes that links into some of the language changes we talked about earlier. You can see bitemporal changes, mesial temporal changes. So that slide, in my opinion, summarizes the extent of the extramotor involvement of PLS. And that sort of challenged my own view when I started. It's not a pure motor neuron disease. It isn't. There's this massive overlap into FTD. And the other thing I would highlight is the cerebellum. The cerebellum is consistently affected in our cohorts, no matter what diagnostic criteria I use. So that's sort of laboring that point and moving away from the motor cortex and the cortex spinal tracts. So if I look specifically at subcortical regions, thalami, pallidum, putamen, again, those regions also get affected. So it's not a cortical disease on its own. It's not just the white matter tracts getting affected, the corpus callosum, but it's very significant subcortical involvement. And then we were talking about response to DOPA and extrapyramidal dysfunction. I find it challenging clinically to dissect what is pure pyramidal, what is extrapyramidal. But certainly there's some imaging evidence that the subcortical gray matter structures get affected. And not only are they affected, they get progressively worse over time. So this is just another way of looking at that. This is what's called, again, vertex analyses, highlighting, so there's a mesh template in blue, and anything is orange is atrophic. So you can see the extent of thalamic or hippocampal and head of caudate atrophy. And again, these are group level analyses with a very stringent statistical threshold. So the data is quite convincing in that there is ample subcortical degeneration. So again, just comparing ALS and PLS profiles, because that's always my clinical dilemma. Can I be confident this patient will have PLS? Will he eventually transition to ALS? So in terms of subcortical involvement, some of the structures that are particularly vulnerable in PLS is the accumbens nucleus, which is this tiny, tiny structure between the dorsal frontal cortex and the thalamus, and it mediates motivation, will to do things. And if it's affected, let it be stroke or a tumor or neurosarcoidosis, patient become very apathetic. So the accumbens nucleus, for whatever reason, is particularly vulnerable both in PLS and ALS. Moving on to hippocampal involvement, again, we don't typically think of PLS as a condition that affects the mesial temporal lobes, yet if you do sort of targeted analyses, the data is fairly consistent and reproducible in highlighting hippocampal degeneration. And you can segment the hippocampus to various subfields. You can look at sort of vertex changes or vertex deformation. So no matter what you do with your data, the signal is consistent. The hippocampus is also affected. This is a study that Matthew has very, very kindly alluded to. I've been interested in language in various conditions, including PLS. Some of my PLS patients would text me or email me, and they have spelling mistakes, which sort of strike me. And I developed that interest in looking at language regions in PLS. So if you run region of interest analyses, it seems that both Broca's and Wernicke's regions are very significantly affected in PLS. And again, it's something that I wasn't suspecting initially, but it seems that the emerging neuropsychological data from the Netherlands, from other countries, would be fairly consistent with that. So this is, I suppose, a more complex study looking at various white matter tracts that contribute to language deficits. And the frontal ascendant tract is one of these tracts that neuropsychologists are interested, and It's a great little bundle to dissect digitally if one has good diffusion data. And this is a tract that seems, in the dominant hemisphere in particular, extremely vulnerable in PLS. And that's, again, something that I wasn't expecting, but the signal is very strong. So in terms of clinical correlates, I use ECOS on my patients because as a neurologist, I don't have the time or the expertise to do very comprehensive neuropsychological testing. But so these are the domains that seem to be affected in the cohort that I have scanned over the years. So language, verbal fluency, memory is affected in some patients. And then apathy seems to be a common denominator as a behavioral domain in these patients. And it sort of links in with what I'm seeing in the subcortical structures. So cerebellum is often overlooked in ALS imaging and in PLS imaging as well. And one of the reasons for that, it's very difficult to image the cerebellum. A lot of the freely available imaging software just ignores anything infratentorial. So FreeSurfer is one of these big, widely used suites that just ignores the cerebellum altogether. EEG studies don't put stickers on the cerebellum. MEG studies typically don't get and acquire data from the cerebellum. And yet the cerebellum is heavily affected in PLS. And you can segment the cerebellar gray matter and you can highlight which regions are particularly vulnerable. But the white matter is also affected in the cerebellum, and the deep cerebellar nuclei are also heavily involved in PLS. So I suppose as a neurologist, one of the things that I tend to overlook is the contribution of the cerebellum to mediating cognitive and behavioral processes. So I often conceptualize cerebellar function as something that helps me with my gait and coordination and speech and all that. But what fascinates me is that there's very significant cerebellar disease burden in PLS. And in a clinical sense, one would wonder whether some of the dysarthria, dysphagia, or pseudobulbar effect is actually cerebellar, or at least confounded by coexisting cerebellar disease burden, or contributing to these very typical clinical phenomena. So the other thing I was going to show you is that in addition to accruing cerebellar disease burden, the cerebellum gets slowly disconnected from the rest of the brain. So not only we are accruing abnormalities in our cerebelli in PLS, it gets slowly disconnected from the rest of the brain. You can look at network integrity in so many ways, and what we try to do in imaging is we show different data sets of the same question to make sure that what you're seeing is real. So I look at connectivity, we look at diffusion imaging, use connectomics, functional MRI, but there's this very nice sort of cohesive message that there's a disconnection between the supratentorial regions and the infratentorial regions. So we talked about progression over time. So I try to scan my patients every 4 months as long as I can. And what you see is this spread. And as a clinician, I suppose, I always thought of PLS as being, especially seeing ALS patients in the same clinic, it's a benign condition in comparison to ALS. Because the patients I see, they don't change all that much in a couple of months' time. I reassess them. I'm not picking up much. I see them again in a couple of months, and they don't change all that much. Yet their imaging changes tremendously over time. So it isn't a benign condition. It's just this relentless progression over time. So this is a single patient showing what's affected in blue at baseline. You can see the motor cortex is affected, temporal regions are affected, and it just spreads, relentlessly spreads, and takes up extramotor regions, cerebellar regions. So PLS doesn't really stop. So if one would run formal statistics on patients who had 4 time-point scans, you can capture that statistically. So I don't see any evidence of plateau. I don't see evidence of compensation. What I see is this relentless degeneration, no matter what imaging metric I look at. So in terms of clinical utility, I mean, one thing that one is always asked are the clinical associations. And PLSFRS is not a good measure in my PLS cohort when I look at imaging correlates. Yes, there is, and they sort of map to relevant regions, so bulbar regions. They correlated white matter matrix in the bulbar representation of the motor cortex. The lower limb function on the PLSFRS scale, there's correlations with the lower limb representation. But they're not very significant. What works much better is tapping rates, like pure UMN science clinically. And I use the pan-UMN scale, which I find very helpful, and the correlations are much better with that. So that helps me to highlight what is the substrate of the spasticity hyperreflexia that I see clinically. The pseudo-Barber effect is again something that is incredibly common in PLS, and we see that in stroke and MS and all other conditions. But PLS is the ideal condition, I think, for us to study that clinical phenomena, and it has a huge impact on the quality of life for our patients. Most of my patients get gradually isolated and they stop going out. They're embarrassed that they were laughing or crying. Big, strong, tall, muscular farmers who wouldn't go out anymore because they're embarrassed to tear up in church or in a pub. So I suppose there's a very high prevalence of pseudo-Barber effect in PLS, and these are the three sort of accepted concepts what the substrate of pseudo-Barber effect is. So the classical thinking is that you lose your cortical control through your cortical Barber tracts. And then there's a concept of cerebellar gating, preventing this outburst of emotional laughter or crying or yawning. I mean, the other thing that we ignore is it's not just about crying and laughing, it's yawning. So I have patients who yawn all the time, and that's part of the pseudo-Barber effect spectrum, which tends to be overlooked. So this is an ideal cohort to understand what drives pseudo-Barber effect. So we designed that study to specifically evaluate these concepts of what's driving it. And what we did find, so I like to do multimodal studies, the diffusion, functional MRI, structural MRI, and we dissected the cortical Barber tracts. So these are tracts that would connect the Barber representation of your motor cortex with the brainstem, because that's the classical thinking that the degeneration of those tracts would contribute to pseudo-Barber effect. And you get these lovely correlations using FA and RD, one of these two widely accepted diffusion metrics. So as the cortical Barber tracts degenerate, you have a much higher chance of getting manifestation of pseudo-Barber effect. And if you look at the same thing, instead of structural connectivity, look at functional connectivity, same thing. So as the brainstem gets disconnected from the Barber region of the motor cortex, the patients will manifest and experience pseudo-Barber symptoms. So on paper, the thalamus is affected, subcortical structures. We can look at the spinal cord now. We can map changes longitudinally. But here's the but. All of these studies are sort of boring, conventional comparison studies, right? You put 40 patients to PLS, 40 controls, 100 patients to PLS, 100 controls, and you map what's affected. So I think what we need to do is making sense of a single patient, because patients don't care what the average survival is in PLS. They want to know their specific trajectory. They want to know what their own disease burden is. They don't care what's the average disease burden in PLS. They want to know, are their own thalamus affected? So I think we have to move beyond these comparisons, to be honest. And we had a great meeting yesterday at NESALS, and people are saying, oh, let's merge more and more data together. But I think the way we should be moving is moving away from group-level analyses into making sense of a single patient data set. And I think while it may be aspirational, that's what we need to do. So if I have high-quality data set from a single patient, let it be functional, structural, diffusion, or QSM, you name it, or can I accurately categorize that patient in the diagnostic category, phenotypic category, and can I predict what's going to happen to this patient over time? So we tried a number of models over the years, and we're not very forthcoming in sharing that all the models that don't work. There's a selection and publication bias of sharing models that are very successful. And one would try 4 different models before publishing one that actually works. And I think that's important to talk about all the models that don't work. So they're very complex and very simple methods of doing that. So I think there's power in simplicity and speed of data acquisition. So I don't think that generating or developing an MR protocol that takes an hour and a half, that's very helpful clinically. I agree with Angela. She came to an ESOS meeting. I think in 15 minutes, we should be able to get enough data to make sense of what's happening with that patient. And I fully agree with that. And I think, we just have to streamline our analyses and protocols to quick acquisition, so that we don't have to repeat the scans. Patients get sick, they start fidgeting. The more interesting the patient, the more extramotor problems they have, the more disinhibited they are, the less likely they are able to stay in the scanner. So I think in 15 minutes, we can sort of crack it, and just at an individual level, I'm able to say which brain regions are affected at that time point. And I can rescan the very same patient and say, okay, well, it's spreading now. So one thing you can do is just look at cortical thickness, and you do sort of a Z scoring approach in various mosaics, and you generate these maps. So let me show you this. This is an individual patient, right? So these are not group statistics. This is one patient I met at baseline, so that's the left column under A. You see these little red tiles which are affected, motor cortex, superior temporal lobe. 4 months later, it spreads. You have more of these red tiles that are abnormally thin. So the motor cortex gets progressively involved. Anterior cingulate, dorsolateral prefrontal cortex, and 8 months into it, the temporal lobe, the insula, and the entire motor cortex is affected. There's some occipital lobe involvement. So this is what we can do at this individual single patient level. So the spinal cord is fascinating, and we now have techniques to actually meaningfully measure corticospinal tract degeneration at spinal cord level. And I think this is sort of where the money is, because if I want to distinguish ALS from PLS at a brain level, I struggle. I tried that many, many times. I got blinded data sets from other countries trying to categorize, doing all my mosaics and imaging tricks and trying to predict is that ALS or PLS. So if I only look at brain data, my models are not great. Once I put in spinal cord data and measure gray matter involved in the spinal cord level, that helps me. Then the detection sensitivity of saying that this patient is ALS or PLS just goes up significantly. So that scoring works, and then you have all these machine learning techniques that is very fashionable, and we all try various models, but we don't talk about the drawbacks and the number of data sets we need and harmonization and all that. So what I wanted to highlight, it is possible to make sense with single scan. We don't have to be collecting hundreds and hundreds of scans. If you have a lot of control and normative data, one can interpret single MRI scan. So I was going to show a few examples of what's been done, what to try to do. And often the trick is do not do binary classification. In imaging, it's incredibly easy to categorize a blinded data set, whether that belongs to a patient or a control. That's never the question. If I see a patient who has signs, I know it's a patient. The question is that PLS? Is that ALS? Is that HSP? Is that transverse myelitis? Is that something different? So we shouldn't be doing binary classification studies. There are a lot of papers out there showing incredible AUCs, area under the curve values, in binary classification. But I think that's cheating. I think you need disease controls. You need to show that your model can distinguish various conditions rather than just separating it from health controls. So features, essentially what we try to do is you retrieve relevant features and you rank them. In practical terms, one doesn't want to run statistics for hours and hours, so you need to simplify your models and pick regions that discriminate ALS from PLS, or PLS from HSP, or PLS from health controls. So these are called feature ranking, feature importance analyses. It's all the same thing. And that's just sort of more examples of the same. So talking a little bit about machine learning in PLS. So I mentioned that we need to move away from binary classification. It's just not relevant in practical terms. Testing cohorts. We need to validate our own models with external data. I need to get MR data from Matthew to make sure that, and I'm blinded from it, to make sure that my model actually works. I shouldn't be using my own data for validation, I don't think. So, and that's where consortia can be incredibly helpful. Features, I shouldn't be looking at specific regions based on what I see clinically or on what I've read. I need to let the data talk. I need to pick up a lot of features and let my statistics rank them, what's important. Models, in general, we should go to unsupervised models if possible. Validations, we talked about it. So external validation of machine learning is very important. And one could argue that, MR alone is just one of the many ways of looking at disease burden. And, if you believe in neurofilaments or EEG, MEG, you can combine all that and figure out which one of those actually differentiate between ALS and PLS. I think, and that's helpful. You can narrow it down for clinical trial. I don't think we need to run EEG, MEG, PET, MR. We need one study when you throw all of this at it and you rank which one of these discriminates best. So one of the final things I was going to talk about is consensus criteria. So imaging is actually quite good at assessing and evaluating breaking news. And that's what we did when the new criteria was published a few years ago. So, and what we found is that the patient with probably PLS, they already have changes consistent with PLS. And so we had a fairly large group of patients who only had a disease duration between 2 and 4 years. And when we looked at their brains, they had the same imaging signature. It wasn't as extensive, but in terms of localization, it localized to the precentral gyres, to the descending cortex spinal tracts, to the corpus callosum. And then a few years later, they convert to definite PLS. So in my eyes, it's a validation that that diagnostic criteria works really well. So that's sort of more of the same, just supported with data that probable PLS will evolve into definite PLS. In terms of the clinical features of patients with probable PLS, it's very similar to what they will eventually have. So, and again, in terms of the clinical profile of patients with probable PLS and definite PLS, they're very, very similar. So in my eyes, it's a validation that these criteria work really well. So I suppose in summary, imaging offers academic insights, right? It showed me that this disease is relentless. There's no plateauing, there's no compensation, there are no adaptive changes of hypertrophy or new networks. It just takes on more and more brain regions over time. And I think there's compelling evidence that PLS affects subcortical structures, the cerebellum, frontotemporal regions, language regions, and the spinal cord. And it's an excellent validation platform for emerging, clinical ideas. The clinical utility is that we can look at a scan of an individual patient when we're not certain of the diagnosis, and we can quantify how badly their brains are affected, and whether that pattern is consistent with ALS, PLS, HSP, or something completely different. And I think while it's tricky to distinguish ALS from PLS, once you look at spinal cord metrics as well, on imaging, you can distinguish patients who will remain in that PLS category and who will not transition onto uppermost neuron predominant ALS. So the way I see the role of neuroimaging is it's just a supportive role. It links in with clinical observations. It helps to validate emerging concepts, and it's a great clinical tool. So that's really what I was going to show you. And I suppose the main message for me is we should be scanning any patients with PLS, suspected patients who don't turn out to be PLS at the end, and keep that data and making sure that we quantitatively analyze it and not just eyeballing it and making sure it's not MS or a stroke or something else. Thank you so much.
Brilliant, thank you. I was pondering while you were giving that talk, if Orla was, I think what Orla says is very true. If this is a spectrum, not a continuum, then it's an extreme PLS. We're not seeing a completely different disease. Isn't what you've found in the imaging entirely consistent with that? From all these studies you've done, all the analyses you've done, if the actual truth is that this is an extreme of the same pathology, isn't what you've found, i.e. that you can't separate them in a simple way, isn't that exactly what you'd expect?
No. So once you look at the spinal cord, what you find is that you have the lateral column degenerating, the descending cortex spinal tracts, but the gray matter regions are not affected. So that's the key. So the key is not brain imaging in PLS when you want to distinguish it from ALS. The key is looking at the spinal cord. Because once I look at the spinal cord of PLS patients, what I do find is that the lateral columns, they're gone, FA was incredibly low. They're scarred, they're gliotic. But the gray matter regions, which I can also quantify, they remain the same. Whereas in ALS, that's also affected. So imaging can help to distinguish ALS and PLS at a spinal cord level.
Okay, so how do we take that forward with spinal cord and produce the data to back that as a routine thing to do?
So spinal cord imaging is more challenging than brain imaging because every time you take a breath, the spinal cord shifts. You have all these artifacts. With cardiac pulsation, you have all these currents, eddy currents and all that. So you have to gate it. You need specialist expertise to acquire the data. But that's the only way, at that present time, I can differentiate ALS from PLS. I use 3 Tesla, but it doesn't matter. People take pride, oh, I have 7 Tesla, 4.5. It really, there's a whole macho element to it. It doesn't matter.
Depends how sick you want to feel with the high Tesla.
So, yes, we use 3 Tesla, but you can get great data at 1.5. So initially, I used to scan patients every 6 months. And then the attrition was so high in my ALS cohort that I decreased that to 4 months. So what I can say is that within 4 months, I see significant changes in a PLS patient. So as short as, now it may be even shorter, I never tried that. So my current protocol scan everybody every 4 months.
But just related to that, you showed some data on the mosaic where it changed over 8 months in a PLS patient.
Sure.
So actually, and we know that the knife edge motor cortex you never see in ALS.
Right.
So it got me thinking really, is the pathology, actually we're looking at this the wrong way around, is there an accelerated pathology of some sort happening in PLS? Because I wouldn't expect to see a change in 8 months in an average ALS patient.
So it's very difficult to rescan an ALS patient. So unfortunately, we don't have that sort of data in an ALS cohort.
But you showed a PLS patient that changed over 8 months.
So in PLS, yeah, we have plenty of data to show there's very rapid cortical spread in PLS.
So is that a way to differentiate them from ALS? They actually paradoxically show more change in the brain.
So what happens, our ALS data is noisy because the only ALS patients you're able to rescan 8 months later are the very slow progressors. So there's a massive inclusion bias in our ALS studies. Yeah. So as soon as the patient has either probable or definite PLS, I try to scan them. As soon as possible, I scan them. It's not symptom onset. We introduce it as a covariate symptom duration, but symptom duration is not very well defined, and patients are often not very consistent with ALS. Oh, I remember having a trip or a fall, or my speech wasn't great, so it's a fairly soft measure, but we introduce that as covariate when we are comparing ALS with PLS. But PLS patients, by definition, have a much, much longer symptom duration than our ALS patients. So that's a massive effect. So all of my PLS patients, just to get a diagnosis, they have a much, much longer symptom duration, whereas my ALS patients can have incredibly short, like 6 months. I run these analyses, the ones you mentioned, comparing upper Montreal predominant ALS versus lower Montreal predominant ALS. I'm not seeing a strong difference at a brain level. So I think what we should do, we should turn the question around. Can you let your imaging data, or can you cluster your own imaging data rather than imposing our clinical observations and categories? So often, we do these studies when we use clinical categories into stratifying patients and then make the comparisons. So I think what we should do is the opposite. We should just do cluster analyses on our imaging data and let the data show us the clusters, and that's the way I would approach it.
Mameda?
So just short notice, a note. I don't believe cerebral changes will be associated with dysphagia, but we see sometimes in these patients with PLS abnormal eyes movements. That has been studied in the lab, but even clinically, sometimes you see this, and maybe that could be associated with that cerebral changes that you have identified so well. So do you agree with this? Can you try to test, did you find this association between eye movement disorders and cerebral changes in this patient?
Yeah, no, we did not. That's the answer, no. So I haven't looked at eye movement abnormalities, or I did not. Sorry.
I'm going to make a small plug for eye movements. The PLS patients, when we did an eye movement study, were among the worst affected. And it wasn't speed, anti-saccade errors. There's a lot more to be done there. Are we talking about wearables today, Hiroshi? Are we going to talk about wearables at any stage? I'm just going to make a plug. People with PLS tell me that they feel unsteady for many years beforehand, and I think that's an area we could get into.
So our imaging proxies for myelin versus axonal, they're quite poor. Essentially, we have two metrics. So axial diffusivity is used to perceived as an axonal marker, and that shoots up in PLS, suggesting an axonal process. RD, which is radial diffusivity, is a proxy of myelination, and that's also affected in the PLS patients. But these proxies have not been well validated by postmortem data. So all of our sense of whether it's axonal, myelin, or neuronal comes from animal studies. And that's where we look at 4 different metrics, FA, AD, RD, and MD, we get a vague sense that most of the changes we see are axonal. But I can't be certain, because these are very indirect biophysical proxies that I am detecting and then running statistics upon. So all I can be sure about is there's degeneration at that level within white matter tract, but the very nature of that degeneration I can't be certain of, unfortunately.
I think we're on time, so thank you, Peter. Thanks so much.
In terms of biomarker discovery, the first thing that I want to point out is that this can't possibly be done in isolation, that we totally need collaboration. And our group is a small not-for-profit group, and we're totally focused on changing patient outcomes. But it is the kind of work that all of you do, and I really want to point out the collaborative nature of this. Hiroshi's contributions have been immeasurable. The CDC has contributed ALS samples. We've got samples from clinical trials from Elijah Stommel in Dartmouth, and of course this natural history group. We recently published this bottom part here showing that we have an 8 microRNA fingerprint that can easily differentiate statistically ALS from PLS. In every one of these, it was statistically significant. And in most cases, that these markers are downregulated relative to ALS, which is an important discovery. Our diagnostic method development is such that we have developed what has been really robust, and frankly, it surprised us that we could do this, because if you look at the literature on microRNA, repeatability in these studies is very questionable in some cases. And so what we've done is from a single blood plasma draw, we are collecting extracellular vessels, and then we are enriching these with an immunoassay to try to get some sort of a small window into the brain from these. And from that, then we're RNA extracting. We've been doing next generation sequencing. We did not do this on the PLS samples because they're so precious and the volume is so low that we use the ALS as a measure of, to do our next generation sequencing, chose from 101 differentially expressed microRNA. We looked at 34 of them with quantitative analysis of PCR. And then from there, winnowed it down to 8, and then compared those back to the PLS samples, primarily from the natural history study to begin with. And what we're working on now, so this is machine learning classification. This is a binary classification at this point, and I'm looking at GLM models right now and logistic regressions, looking at multiple categories. But if you look at this, what you see, so our PLS sample at this point is only 67, and typically when you're doing machine learning, you want 10,000 data points. 200 is kind of as small as you can go. So in our very first study that we published, we did not want to include any machine learning with PLS because the sample size was at 42. We've been able to increase that now to 67, which is still, it is suspect to overfitting. There are lots of concerns with really small sample sizes like this. However, if you look at PLS to controls, we have no, you would never confuse those two. Complete classification accuracy with controls, but that's not the group that has any any measure of importance, because you would never take a healthy person and say, gee, do you have PLS? At least not at this point. But when you compare it to and if you look at the bottom one, PD, which we have again a really small sample size of PD, and so I very cautiously did this, but we can easily separate PD from PLS. The middle one is ALS, and it's not too bad. The problem is that with this random forest model, we're taking an 80% split, so we do training on 80% of the data, and then we take 20% of the data. And so the reason I put, the false negatives and false positives up there is you can see by the end, even, with considering how rare PLS is, this is a pretty good sample size. Still, we're getting, you're looking at 13, which is not enough. But the accuracy is pretty good. We've got 90% accuracy separating ALS from PLS. And I think with larger sample sizes and better neurological controls that are linked directly to PLS, that we could get some amazing data out of this. And so I personally would really like to know what sensitivity or specificity would be clinically helpful. Thank you.
Thank you.
Hello, everyone. Ikje from Columbia University. My focused interest is in metabolism, studying in ALS and PLS. I'm honored to be here to talk about lipidomics as a diagnostic biomarker distinguishing PLS from ALS and those without motor neuron diseases. So you might have heard about lipidomics or metabolomics. Lipidomics is a large-scale study of lipid metabolites and their network in a biological system, and is kind of a part of metabolomics. Blood is a common sample for lipidomics, but other tissues like muscles can also be used. And as you can see in the figure, the prepared sample would go through lipid extraction, and then separation with lipid chromatography, quantitation with mass spec, and then the signal will be read out and analyzed. Resulting lipidome can be used as a fingerprint to represent underlying metabolism. So we talked about this, and we understand that the key differences between ALS and PLS is that in PLS, lower motor neurons are largely spared or intact. Functional change is very slow. And this is less recognized, but their metabolism also quite stable. In this figure on the lower side, you can see that the red dots representing ALS individuals, blue dots representing people with PLS, y-axis with a change of PLSFRS monthly, and x-axis change of BMI monthly. And you can see that in ALS, in the red dots, they're all over the place, losing a lot of PLSFRS and BMI over time, while PLS patients are both stable with their function and also with BMI clustering around 0. And this similar observation can be seen with lipidomics. So in our study of ALS and PLS Cosmos cohort, about N of 100, ALS 40, PLS about 30 in a healthy control, we observed that increased and decreased concentration of various lipid classes, as you see in figure A, among ALS patients, red representing increased lipid concentration, blue representing decreased concentration. Similar patterns observed in PLS too, but not all the same. Strikingly, in the follow-up samples, there's a dramatic change in lipid concentration among the ALS patients, while you can see that the change is quite subtle in PLS. When we use clustering methods like OPLSTA, we can cluster ALS and PLS patients based on their lipid profiles, and using the machine learning algorithm, such as regression, regularized regression, we were able to differentiate PLS patients from ALS with 100% accuracy and PLS patients from controls with 88% accuracy, which is quite promising and exciting. Lipid species such as phospholipids, glycerides, sulfatides, acylcarnitine species contributed the most in this differentiation and will be of interest. So once again, I think our results suggest that lipidome profile might serve as a biomarker, and we plan to confirm our findings by using PLS natural history cohort. The unique advantage of this PLS natural history cohort is that we have an only PLS patients with less than 4 years of disease duration, those with probable. And it'll be very interesting to see whether the lipidome in this group can differentiate patients from ALS and also predict their future disease course, whether they stay as PLS or they later progress into ALS. We plan to also use NFL as a benchmark, which is another great candidate marker. You'll hear more about NFL in the later sessions, but with known limitations that NFL among PLS patients overlaps significantly with ALS and also with healthy controls, as shown in this figure. Now, this sounds all promising, but there are challenges that lipidomics is always having issues with methodological heterogeneity, meaning how they analyze lipids among different labs are different. Lipidomics is not always available, and the cost is still quite high. There are different ways to do lipidomics, such as targeted, untargeted, absolute versus relative quantitations. Sometimes make it difficult to compare data between different experiments. Also, how you analyze it with machine learning, the results might vary based on the approaches you use. So with these limitations in mind, we need to address them as we move forward with lipidomics. Thank you, everyone.
Good afternoon, everyone. Before starting, I just want to thank the organizer for inviting me here. It's a real pleasure to talk to you today about biomarkers in primary lateral sclerosis. So, as you know, patients presenting with dysarthria and limb spasticity fall under the umbrella term of the upper motor neuron syndrome. And according to the current diagnostic criteria, at least 2 years of follow-up are required to exclude the lower motor neuron involvement and to diagnose with PLS. However, the differential diagnosis entails relevant consequences for both prognosis and management, since PLS patients present a significantly longer survival and less disabilities during disease course. But in the recent years, some wet biomarkers got under the spotlight for their prognostic potential, and among them, neurofilament light chain is actually one of the strongest predictors of prognosis. Moreover, other two wet biomarkers, namely GFAP, which is a marker of astrocyte involvement, and UCHL1, which is a multifunctional protein expressed by motor neuron, has recently been suggested. For this reason, the aim of our study was to evaluate if a panel of wet biomarkers could be helpful to reduce the diagnostic delay in patients presenting with an upper motor neuron syndrome. And for the aim of the study, we retrospectively collected the clinical and electromyographic data at disease onset of patients presenting with an upper motor neuron syndrome from 2001 to 2023. For a subset of our study population, a serum sample at the first neurological examination was available, and biomarkers were measured from a SIMO assay. We then collected the survival data and time to meet stage 1, which is based on the LS functional rating scale, through periodic neurological examination and phone calls. Our study population included 105 patients and was made up of 55 PLS patients and 50 ALS patients. At disease onset, we observed a significantly longer time from onset to the first neurological examination among PLS patients, and a slower disease progression rate in the PLS group compared with the ALS. Moreover, we observed a significantly lower rate of electromyographic abnormalities and a lower rate of bulbar onset in the PLS group. We then evaluated our panel of wet biomarkers in the two populations, and we observed a significantly lower concentration of NFL in the PLS group. For this reason, we performed a ROC curve analysis, which disclosed a good discrimination profile of NFL, with an error under the curve of 0.78. We then evaluated the relationship between NFL levels and the disease progression over time, and we observed that low levels of NFL, basically below the 200 level, could not distinguish between early onset with mild disability ALS patients and PLS patients with a longer disease duration. For this reason, we performed a binary logistic regression analysis, and according to our model, the variables that were highly suggestive of a lower motor neuron sparing during disease course were represented by a longer time from onset to the neurological examination, an absence of electromyographic abnormalities, and a lower NFL concentration. We then performed a univariate and a multivariate analysis, which confirmed the prognostic role of NFL when grouping the entire population according to its median value. And this brings me to our conclusion. So according to our results, NFL levels are significantly lower in PLS patients at disease onset. Time to first neurological examination together with NFL levels and electromyographic abnormalities represented the best model to predict the final diagnosis in patients presenting with an upper motor neuron syndrome, and NFL levels were confirmed to be an independent predictor of prognosis. This is the last slide. I just want to thank all the collaborators of the neurology unit, the neurophysiology unit, all the lab members, and all you for the attention. Thank you.
So I'll be talking about upper motor neuron biomarkers for PLS trials, and this is an ongoing study, and of course many members here told that this is like a team effort. It is indeed a team effort, and I'm very thankful to all my colleagues and collaborators who helped me with their very precious human samples. And we received DoD grants, about $1.5 million, to be able to identify potential biomarkers that would tell us about the involvement, the timing and extent of upper motor neuron involvement in ALS, in HSP, in PLS, and potentially pharmacokinetic biomarkers that tell us longitudinal changes in patients. So I've been working with Dr. Paganoni and Dr. Berry at MGH, but Lauren Eyman was very kind to give me samples. Rizwan was very helpful to give at Northwestern, and Jeff Rothstein actually opened some of the samples that he has at Northwestern. So I'm going to tell you about what we have done with bottom-up proteomics, but we also do top-down proteomics, and they're very different. Bottom-up is actually chops down the proteins, and then reads them, and then puts them together and says, this is what the protein is, I think. And then it also looks at the quantitation of the protein. And the top-down protein does not chop the proteins into little pieces. It reads as is, and that's very important because then it tells you about post-translational modifications. If there's, let's say, any simulation, any phosphorylation, any also cryptic sites or splice variations and so forth. But those studies are still ongoing. We still have our DoD grant in effect. But basically, we're looking at here I'm going to show you very preliminary results, but I want to bring to your attention two important proteins, I think. So we had ALS patients with predominant upper motor neuron loss, and also ALS patients with predominant lower motor neuron loss, okay? So you're going to have grouped the ALS patients. Then we have PLS patients. I have HSP patients, but I didn't include them in the slide here. Then we have the age and sex matched control cases, and we have serum and plasma or plasma from the same patient. And okay, so now one of the proteins that really came up is the SERPIN-A11. This is in the plasma, and if you look at the PLS patients and versus the upper motor neuron ALS patients, SERPIN-A1 was statistically significant in the PLS patients. And we thought that's actually very interesting. And also, it is statistically significant when compared to control cases as well. And it may be that a very quick ELISA test with SERPIN-A1 may give you an idea whether these patients have more if it can distinguish ALS and PLS. And I'm not going to talk about the SERPIN family of proteins, but then we also found another SERPIN protein, SERPIN-D1. And SERPIN-D1 was statistically reduced in the PLS patients. So you have one SERPIN family very high, and you have another SERPIN family very low. And again, the numbers that we have, patient numbers, are not very high, but they are clinically well-characterized patient populations. And it's a nicely controlled study with the age and sex match controls. So it seems that there's really a difference between the SERPIN families. And if you look at the SERPIN families, please take a note of those, like SERPIN-A1, A2, A3, A4, A5, A9, A10. So, I'm not going to show you the results of those, but they also seem to tell us something that help us distinguish the HSP and PLS patients. So certain family of proteins are important proteins, and we think that they could really be informative when it comes to distinguishing PLS patients from ALS patients, even the ALS patients with predominant upper motor neuron loss. And I suggest that we study the Sherman family members with greater detail. That's what we're doing in our lab. And we are also studying them with the top-down proteomics, trying to see if there are any differences, like post-translational modification differences. But it may be that this family of protein is also important in the lipid biology. It's important in protein folding. It's important in many things that are actually related to upper motor neuron vulnerability and degeneration. So these proteins actually may be important, and that's why I wanted to share this with you today. Thank you so much.
Can I ask you, do you think the serpents are protective, or they're important from a pathogenic point of view? Because if we think that PLS is primarily a restricted form of a wider disease, notwithstanding Peter's observations, do you think the serpents maybe, do you think they're of pathologic significance in terms of causing the disease, associated with disease, or protecting against a wider degenerative process?
So that's a very good question. And, you know, because of the family has more than like 23 members, I think it's important to find the signature. Like, for example, you may find A positive, B positive, but C negative, you know, and what combination is protective, what combination is detrimental. We can actually do some tissue culture studies and also animal studies to be able to see that, and I think those are ongoing.
Thank you very much. Thank you. This is a neurophysiological biomarker. So intermuscular coherence has been around for decades in the investigational level, but what we're trying to achieve is to make a software for a test that can be done on the conventional EMG machines by every electromyographer and in a very short period of time. And our study has been funded by these agencies down there. And the background is that there is measurable coherence. It's a functional connectivity between the electrophysiological cortical recordings, such as magnetoencephalography, electroencephalography, and EMG waveforms that are simultaneously recorded in the contralateral limb muscles, in the beta and low gamma frequency bands. On the other hand, that is called corticomuscular coherence. Our test, our method is named intermuscular coherence when we gather surface EMG signals from two muscles, in this case, biceps and brachioradialis, during a very simple motor act, in this case, holding the arm against resistance. And you do coherence analysis on those pair of EMG waveforms, and what we and other groups have shown is that in the normal controls on the left side, you have measurable coherence, whereas in upper motor neuron conditions, such as PLS, the coherence diminishes or is abolished. So these are the center. This is a multi-center study. Many of them have, four sites have been involved, including Dr. Benatar and Joanne have kindly contributed largely to this study. This study we have done on the lower panel on the right side. This is a scatter plot of intermuscular coherence beta gamma in 20 PLS patients, and we also have included 115 neurotypical subjects and some early ALS cases. Those are possible according to the Awaji criteria, or or the patient although had a clinical diagnosis of ALS, it could not be classified according to the Awaji criteria. We did not include patients with the definitive or the probable classes of the Awaji in this study. We also have included some patients with lower motor neuron disease and myopathic conditions. And there are two dashed lines on the right lower panel. The lower one is the confidence limit. That is, anything below that is considered noise level and equal to 0. The upper dashed line is a pre-specified level that for the biceps brachioradialis that in a previous study could differentiate ALS, established ALS, from the neurotypical subjects. On the top panel on the right side, the diagonal line, the black line, is anything below it is the p-value. As you see on the lower level, a lot of PLS and ALS are below the upper dashed line. And this test can, on a population level, can differentiate ALS and PLS from neurotypical and lower motor neuron / myopathic conditions. And to show it, here is the ROC curves. Again, the PLS has the highest ROC curve, meaning that the best ability to distinguish the IMC beta gamma has the best ability to distinguish PLS versus the neurotypical, and then ALS, and then myopathies and lower motor neuron diseases do not distinguish, which is versus neurotypical, which is consistent with our hypothesis that it's a biomarker of upper motor neuron diseases. Thank you.
Hi, I'm David Shaw from the Mayo Clinic in Florida. Thanks for inviting me to give this talk. I'm going to share our experience of using 7T MRI in our clinic. So the motor band sign is hypointensity of the precentral gyrus, which you can see on T2 star, T2 weighted, and SWI imaging in patients with motor neuron disease. And susceptibility weighted imaging is a sequence that we use routinely in clinical scans, and it generates contrast differences in tissue magnetic susceptibility. It has what causes differences in magnetic susceptibility are differences in iron in blood products, ferritin or calcium, and some limited pathology has been done. Post-mortem studies have been done looking at patients with the motor band sign, and they can see intracellular iron in microglia located in the middle and deep layers of the motor cortex and post-mortem ALS brains. So in our study, we looked retrospectively at patients seen in our clinic who were referred clinically with concern of motor neuron disease. And I subdivided those patients into those who we thought had ALS or PLS and those with the low clinical suspicion of ALS or PLS. We also looked at MRI scans of patients referred for other indications like headache, multiple sclerosis, etc. We quantified clinically the upper motor neuron involvement by this motor neuron score. So we scored individual reflexes on a 0 to 4 scale, and we summed these reflexes to generate a summed reflex score. The MRIs were reviewed by 2 neuroradiologists who were blinded to the clinical data. The degree of hypointensity in the cortex, in the hand, foot, and bulbar motor regions were scored on a 0 to 3 scale. And from that, the scores were summed to a total SWI score. We also had plasma neurofilament light chain data in about 80% of patients. We had 48 ALS, 14 PLS, and 19 subjects who were referred with concern for ALS or PLS. We did not think that they had that clinically. And we looked at the 33 cohort, 33 patients without referred for other reasons. And in the ALS, PLS, and mimic category, the ages were pretty similar, but in the control group, the age was younger, and this is probably due to the reasons for referral. The PLS and control groups leaned heavily female. So this is the data on the summed SWI score and correlation with clinical and laboratory factors. And the summed SWI scores were much higher in patients with ALS and PLS versus control and the mimics. Out of all the factors we looked at, the upper motor neuron score is the only one that had a significant correlation. If you look at the number of patients with any SWI change in the motor cortex, just over 90% of ALS and PLS had at least one area of a score of 1 or greater, whereas 5 in the mimic and control groups had SWI change. Although if you look at the sum scores in these categories, they are much higher in ALS and PLS. And in the groups that had the control group or the mimic group, none of them had a score that was greater than 1 in any region. We also noticed that the SWI change in the motor cortex in ALS and PLS often had this layered or laminar appearance, which has been described in some autopsy series of seeing iron deposition in macrophages and microglia in the deeper layers of the motor cortex. And we could actually see that in some MRI cases. And looking at our data, only about 75% or so of ALS and PLS had this, we could identify this laminar appearance, but we didn't see this in any control subjects or in the mimic subjects. So to summarize, the SWI score, or SWI changes of the motor band sign in ALS and PLS has some correlation with clinical upper motor neuron findings, which could mean that it's a biomarker of upper motor neuron degeneration. And the motor bands in people with ALS and PLS versus healthy controls tend to be in the moderate to severe range of SWI hypointensity, and we're more likely to have a laminar appearance. So some future directions, we would like to look at some pre-symptomatic patients, pre-symptomatic gene carriers, and we would also like to look at some other clinical phenotypes like HSP and atypical Parkinsonian syndromes. Okay. Thank you.
Okay, thank you.
I have a question. I suppose the hemoglobin eaten by macrophage. Do you have a pathology? Why microhemorrhage over there in the cortex? Can you imagine?
Why are the microglia in the motor cortex?
Yeah, microglia or macrophage eating up hemoglobin. That means hemorrhage. Microhemorrhage.
So is the M band, it's iron deposition, so is that microhemorrhage? Or what's the basis of the iron deposition? That's the question, yeah. Yeah.
Yeah, I don't know that we know the answer to that. When microglia are activated, they tend to have more ferritin or iron in ferritin. So iron, yeah. So I think it's just a measure, it could be a measure of microglial activation.
So
if you have pathology, then fantastic.
So there is a Target ALS funded project that is looking at that actually, looking at clinical and then pathology. Yeah. Yeah.
Thank you. This is a very clinical panel, and we have less speakers. We are going to talk and discuss about PLS ALSFRS and other outcomes for clinical trials. So the first speaker.
Thanks for the opportunity to present here. What I'm going to do is to present the outcome of PLSFRS in the natural history study that has been mentioned a couple of times. But first, I'm going to recap. The cohort has been mentioned briefly this morning, but just a recap on the characteristic of the participants. So the data cut is November 4th this year. We had enrolled 76 participants. We have followed visit schedule baseline 3 months up to 24 months. Mean time of single onset is about 6.2 years in this cohort, and majority of the participants are categorized as probable PLS, 58%. 34% of them were probable PLS, and we have very few patients who are early PLS, and the mean age is 62, relatively even distribution between male and female participants. So this is really the characteristic of the cohort, and the primary endpoint of this study was PLSFRS, as you can see in the figure to your right. So for those, you're all pretty familiar with the scale, but it is a scale from 0 to 68. High is good, low is bad. So we see that there's a relatively steady decline over time. If we fit the model, the decline is about 0.28 per month on a scale of, again, 0 to 68. So if you think about a 1 year span, it'll be about 3 to 4 points of decline over 1 year on this scale in this cohort. And there are three patient group subgroups, and we have early PLS, probable PLS, definite PLS, and we see that the decline rate are very different, right? So, and the early PLS participant had the biggest decline, like a decline 1.05 on the PLSFRS scale per month, and the definite PLS had the slowest decline, and this is pretty much the same experience that you've known, that this is a relatively slow progressing disease. But it has implication on when we want to intervene on these participants. So whether we should intervene them on at an early time point, or we want to enroll more participants so that we're going to have a larger sample size. So and this is also indication that risk stratification might be useful based on the symptom onset. Last slide is about the subscale. As you know, PLSFRS has there's 9 different domains plus 3 additional questions, and basically the same analysis. We see that in the first 9 subscale, from speech to stair climbing, there's a constant decline on all these scales, and they're all statistically significant, and they're pretty stable in terms of the rate of decline. On the last 3 revised scale, however, we did not see any significance. So this may also be considered in terms of what we want to include in the primary endpoint in the future clinical trials. So, thank you.
Thank you. Just a very short comment about this. We found that early patients, they progress more. I mean, we can wonder if some of them have ALS, really, because they are in very early phase, so it is not fine, the diagnosis. But, I mean, it could be done, I don't know if you did, I mean, multi-regression analysis, considering it has predictive factors for progression rate, the time, because you have patients with this very short disease duration, patients with 17 years of disease duration, so time and the category, early or probable or definite, could be predictors. So did you try that on a multi-regression analysis model to see if there was, some of them could be independent predictor of progression?
So I think there are 2 ways we need to be a little bit cautious about interpreting the data. First of all, that there's this regression to the mean possibility, as you suggested, that because they're early, so over time, everyone may regress to the same plateau. And the other nuance I did not mention is that the sample size in the early PLS group is extremely small. We're only 6 participants, so I would not really try to overinterpret that. But so that's why that analysis is particularly difficult to do.
Okay, thank you.
Hi everyone, I'm Grace from Columbia, and I'll be discussing the secondary outcomes for the PLS natural history study. So we'll be discussing 7 assessments. The first 3 are questionnaires, and the last 4 are in-person evaluations. The first one, NeuroQOL upper extremity, measures the ability to perform fine motor functions and activities of daily living, and the score ranged from 20 to 100 points, with higher being better. For the NeuroQOL lower extremity, this measures the physical function, mobility, and overall quality of life related to the lower body. For this, the score ranged from 19 to 95 points. Again, higher is the better score. And the RASH overall ALS disability scale measures the overall impact of M&D on daily activities, and a score range from 0 to 56, with higher being better. For the timed up and go, participants were required to get up and walk back and forth 3 meters with or without devices. And for finger tapping, so participants would just be tapping their index finger and thumb together like this for 10 seconds. For foot tapping, just to show you, so they would just tap their foot like this for 10 seconds. And lastly, pataka is repeating pataka as fast as they can for 10 seconds. So in terms of outcomes, for the questionnaire, so if you can look at the graphs, the bold gray line is the pattern for all 3 groups, so definite, early, and probable. Green line is for the early PLS. Yellow line is for probable PLS. Red line is for definite PLS. And the table below shows the outcomes for different PLS types. N is the number of participants in each group, and the mean score change per month for each group, and the p-value. If the p-value was significant, it's highlighted in yellow, and a p-value of 0 just says that it was very small and extremely significant. So for the upper extremity, you can see that there's a similar pattern of decline between probable and definite, but the early group decline is much faster, especially between the 0 and 3 months. Similarly, for the lower extremity, the pattern of decline is much slower in the probable and definite group, much faster in the earlier group. And lastly, for roads, there's a stable decline in the early group and a much slower decline in the definite and probable PLS groups. And the p-value for all these groups are statistically significant. Moving on to the functional assessments. So for finger tapping and foot tapping, the pattern is very interesting. For the finger tapping early group, from the 0 to 3 month mark, there's an extremely fast decline in the number of tappings. And for the definite group, it actually slightly increased. But this could also be because participants were practicing finger tapping once they knew how to do it. So that could indicate the increase. But it's also important to note that the statistical significance wasn't there for the definite group. And for foot tapping, again, a very fast decline between the 0 and 3 months for the early group, and a slight improvement for the definite group, but this is most likely due to the ability to rehearse the foot tapping, excuse me. And for pataka, similarly, the decline is much faster in the earlier group and more so stable in the definite and probable group. And lastly, for the timed up and go, this kind of flipped. So for the early group, there really wasn't much change. As you can see, the p-value was a 0.316, and the change was not statistically significant. Similarly, for the definite group, not much change. The p-value was a 0.847. Whereas for the probable group, there was an extremely stable increase in the amount of time that it took for them to walk, and then the p-value was a 0.028.
So thank you very much. I mean, about this, I mean, the early patients, they decrease very quickly, in particular the bulbar function. So again, there is a question about we are dealing possibly with ALS patients because they have a really striking decline of the bulbar function.
Yeah, so as Ken mentioned, the sample size was very small, but there were a few early PLS patients who had change in diagnosis from PLS to ALS.
Yeah. Right. My name is Dara Heitzman. I'm in Dallas, Texas. I was part of the EMG committee for the PLS natural history study. I'll show the participants on the committee at the end. We took the idea and said, what is PLS? What is ALS? And by electromyographic features, we said, if the most recent criteria are the Gold Coast criteria, we'll say that's ALS, and everything behind that is PLS. To qualify for ALS, you had to meet the Gold Coast criteria. So members of our committee reviewed EMGs, and we selected these muscles. Maybe we should have had a few more to increase the numbers that converted to ALS. But we did the tongue being the bulbar, 3 muscles in the upper extremity, thoracic paraspinal muscles, and 3 in the lower extremities. We asked that the EMG studies be performed approximately 12 months apart, preferably with the same examiner and on the same side of the body. For those of you who don't know the Gold Coast criteria, the criteria where you had to have chronic neurogenic motor unit potentials and active denervation, which was considered either fibrillation and positive sharp waves or fasciculation potentials. And I have a criticism about that, which I'll talk to in the last part. 65 patients had a baseline EMG and a follow-up EMG. There are more to still come. As you saw, the numbers are in the 70s. There were 30 sites participating in the United States and Canada. From our group, 5 patients converted from PLS to ALS. And here's a summary of some of their clinical features and when this happened. Look at this. 2 were female, 3 were male, in their 50s and 60s. 2 were probable, and 3 were definite. The time between the EMGs is listed here. One of them, man, who's my patient, was at 7 months. He insisted on having an EMG early. He was also rapidly progressing. And in summary, I think that the EMG is a reasonable, it's not the most, it's good, electrophysiologic measure to determine the conversion from ALS to PLS, relying on the Gold Coast criteria. Now, I said I had a question. We did not do motor unit variability. We tried to make this very simple, and again, based on the Gold Coast criteria. Looking at the Gold Coast criteria, and I think this is important for all ALS trials, looking at EMG data, historically, if you look at these Lambert, Asa Wilborn have since passed away. I know I was taught by them, so is Eric. We were told, be very cautious about making a diagnosis of ALS if there's not fasciculation potentials. We still make it, but be very cautious. Currently on the Gold Coast criteria, it says it's either or, either fasciculation potentials or positive sharp waves and denervation. I personally would be very hesitant to make a diagnosis of ALS if there's not active denervation. And that's, I know my plug to make some positive changes. And that's all I have to say.
Hi, it's me again. So it's not two different persons. It's the same me. So it's still Ken Chen from Columbia. So I think the focus, the focus of really this session to me is that so this morning, by the way, I'm new to this community. I learned so much about this, and thanks Hiroshi for bringing me into this really wonderful community. And so I'm pleased to see that there's so much progress done in terms of diagnostics. But I think this is a time exciting time to move from how to define the disease to really cure the disease in clinical trials. So I think, so what I'm going to talk about is what steps are needed for us to get us into trial readiness. And basically, I'm going to go over this through the FDA guidance on how to develop drugs for rare diseases. And so I think So you can look up the resource at the FDA website. And the number one issue that is very exciting about this community is that we need to have a natural history study, and that's what exactly we've presented here, to have a natural history study in which participants are followed longitudinally. And there are two ways that we can use the natural history study to plan the clinical trials. Number one, we define the benchmark. So if you remember the numbers that in this cohort, the average decline of PLSFRS is 0.28 per month. This is the benchmark. How do we want to improve it from a decline of 0.28 to 0.14, a 50% improvement? So this is a study that gives us that benchmark to determine how we want to move forward. The second way that we could use a natural history study is really to define the stratification based on baseline risk factor. So in this particular cohort, we realized that time from onset is very significant in terms of predicting the trajectory of the participants. So we probably need to include that as a stratification factor in order to reduce the variability in the trial. So this is the way that we could use a natural history study to plan the clinical trial. A few more other considerations in terms of the treatment itself. How much do we know about the intervention? Do we know the dose? Have we done the safety study in preclinical studies and in early phase 1 studies? So I heard that there was a phase 1 study ongoing. I think that's primarily a safety study where we want to relook at the intervention. And whether we want to look what biomarkers that we want to look at. So I'm pleased, again, there are lots of discussion about diagnostic biomarkers. What I'm talking about here is prognostic biomarker or even pharmacodynamics response that we can use to be prognostic about the outcome of the participant. And one suggestion has been using neurofilament, which is reasonable. But I think I'm pleased to see that in the previous session about people really look at different ways from imaging, RNA, and to define the biomarker. The question is whether you can use that diagnostic biomarker as a prognostic biomarker, as a way to see whether the treatment is actually working. And of course, we don't want to improve the biomarker alone. We eventually want to improve the clinical outcome of the participant, of the patient. So we need to have a clinical endpoint at the end. We need to determine how long we should follow the participants, whether the clinical endpoint is sensitive to treatment, right? So we want to have an endpoint where that indicate that reflects the disease progression over time. So PLSFRS a constant decrease, so that seems to be a good clinical target that we want to improve upon. But the value of biomarker is important here. So if we can take the playbook from Tofferson study for ALS patients, I'm sure most of you are familiar with it, that we basically did not find a significant difference in terms of clinical outcome during the blinded window, but we did find a significant difference on the neurofilament light during the window, but it turns out that it's predictive of the benefit in extended window on the clinical outcome. So this is where the biomarkers is important, and so this is something we need to think about. How do you use your knowledge of diagnostic biomarker into prognostic biomarker? Some example to see. To illustrate the point that how we can use a natural history study to determine the sample size, and to inform the type of population endpoints we want to look at. So just to think about using PLSFRS, let's say a 12-month change. If the goal is change from a 3.4-point decline, which is what we observed in the natural history study, to a 1.7-point decline over 1 year, which represents a 50% improvement, an RCT will be requiring 85 participants per arm, so it's about 190 participants overall. But if you want to enroll to a high-risk group where we expect a bigger decline, the sample size requirement will be much smaller. So it could be as low as 10 participants per arm, but if we look at the early PLS participants. So it's a drastic reduction in the sample size requirement to detect an effect size, the same effect size. The question is, of course, that those patients are rarer, it's harder to enroll, and so this is really the trade-off between whether you want to target a more homogeneous population or more general population, where we have a bigger sample size to deal with. And the last tool that I would like to offer to you is the use of adaptive design for clinical trials. And I think there have been a lot of discussion about whether we care about PLS alone or we want to just extend it to upper motor neuron diseases. One idea is to do a platform trial, right? So we can use a platform trial that have different bucket of participants and to enroll them together. And so there are really a lot of tools that we can use in clinical trial design to help further to really evaluate intervention for this patient population. So I think that's my last slide, and thank you.
I'd like to stress just one thing about awarding criteria. In awarding criteria, there are two lines that are not very well remembered. I mean, one is that the fasciculation has the meaning of fibs and sharp waves in the right context of a patient with a suspicion of ALS. And that particular point, fasciculations and chronic neurogenic changes, has meaning fibs, sharp waves, and chronic neurogenic changes, are especially important for strong muscles and cranial innervated muscles. They are written. And that is because, of course, we agree that when we are observing atrophic muscles, we expect to see fibs and sharp waves. But that particular point was not for atrophic weak muscles, it was for strong or cranial innervated muscles. And I remember that in 1969, Ed Lambert wrote that he would not diagnose a patient with ALS without fasciculations. And so this is a kind of re-stress of the Lambert proposal. We had the Lambert criteria, but I'm not going to describe them.
Hi, everyone. You have to wake up now and be ready. So we are going to start with Senda Dress, who's going to talk about eligibility criteria.
Hello, everybody. It's really exciting to be thinking about actual designing clinical trials. And I wanted to take you back a little bit and try to think about the reason why we have eligibility criteria. And they are important because they help us define the population we're going to study. They allow us to assess the effectiveness of the therapy. They limit heterogeneity, and at the same time, the data has to be generalizable and will help us select a population that will adhere to the protocol. But I remind you that we're doing this in an ultra-rare disease, slowly progressive, has significant diagnostic delay, and the natural history study results are just coming up. So please don't kill me, the inclusion criteria. So we talked earlier about using the diagnostic criteria versus actually selecting patients who are slow. And it is interesting to see the curve of the patient that progress very quickly that we saw earlier that can help take patient out. So in thinking about that, what do we do with upper motor neuron predominant ALS if we're trying to select patient early? So again, we can design a study to include either true probable definite PLS versus just slowly progressive disease. The age range is easy if we follow the diagnostic criteria. What do we do with disease duration? Should we focus on an arbitrary number, or should we, on the opposite, decide about actual disability, the ability to walk a certain distance, the ability to speak, so if we're collecting speech. And then, of course, I know we're not ready to use neurofilament as an entry criteria, but it seems to be, so far, the best we have, and maybe if we don't use it for an entry criteria, it's important to use it as an enrichment or stratification. And then my last thing is, should we have a PLS risk profile like we do in the TRICOS, rather than go stepwise, univariate? Maybe we should think, hopefully get the data from the natural history and develop a risk profile. The exclusion criteria are simply kind of straightforward, right? I mean, we want to exclude ALS patients, we want to exclude genetic disease, severe comorbidity, or cognitive impairment that will preclude the participation. And that's it. I spoke as quickly as I could.
So question. If we want to get patients in early, and so we call them PLS based on the criteria, but they eventually develop lower motor neuron symptoms, so that we're saying, okay, it's an upper motor neuron is that really bad? Or is it okay to have those patients in the trials? If you think about the fact that we like to treat patients early in their disease course, so we will end up with some with lower motor neuron eventually. What do we do with those?
I think it's more about including PLS in trial rather than worrying about lower motor neuron disease patient. And I think this is going to be answered by clinical trial design. I mean, you heard Jency saying about basket trials, so we could think of trials that put patient in categories so we can get a bigger number of patients. I think it's about time to be really thinking about getting PLS patient in trials. So we want to get them in rather than the other way around.
Okay, so second question then. So if we do that, we're going to have to figure out some pre-specified analyses and how to separate those patients who develop lower motor neuron symptoms. So does that, if you really want to do a PLS study and it's upper motor neuron, should we limit those patients to drugs that we believe are more central in action, or should they also be exposed to there's a whole series of new compounds that are looking at the axon, the distal axon, the neuromuscular junctions. Should we just ignore those for PLS?
I think, do we think that the upper motor neuron degenerate differently than the lower motor neuron? And that's the question. If we think that, yes, we will have to limit and use only centrally acting drugs. But if we think that neurodegeneration is the same, I guess we'll have to be more inclusive.
Okay, good. Okay.
Yes, the other thing I didn't talk about, and I forgot actually, is what do we do with EMG? Should we have an EMG at the entry, like we did for the Atlas study, for example?
Okay, good. Dr. Kano.
Hello, everyone. The title is, can we make PLSFRS universal? And the answer is yes, we can. So today, I'm going to tell you about the process to make the Japanese version of the PLSFRS so far. The first step is translation by translational agency. And the second step is to seek for the neurologist who sees the PLS patients. And the third step is create the modified version that considers the Japanese lifestyle. That means minimal change, like chopstick problems in LSFRSR. And the last step is make the instruction. And this is a method, and P is a primary evaluator, and S is secondary evaluator. And we also check the interlator and interlator reliability. And the consistency of PLSFRS total score between the face-to-face and telephone interview was assessed at 4 weeks after baseline. Before I tell you the result, we make the instruction guide. The left column is original version of the PLSFRSR, and the center version is just translate in Japanese by translator, and the right column is instruction guide. And as you know, PLSFRSR is very detailed. The change is very small. So we spent more times to make the guide instruction. And the results are very nice, both reliability and consistency. And I also show you the results at the LSML meeting. And so the summary is LSFRS is more detailed than LSFRSR. So sometimes the evaluation is confusing, but we cannot change the Bible. So we think it is important to success the clinical trial is to make the instruction guide.
So I have another question. So I'm allowed to ask questions. So have you looked at making Has anyone looked at making the PLSFRS a self-report version of the PLSFRS? Or are we still relying on rater assessment of the PLSFRS? Dr. Kano, do you know? Is anyone working on that?
Just not tried yet, but it is it's important to make just self-report version of the PLSFRS.
Okay.
Yeah, but more difficult than LSFRS are.
Okay.
Yeah.
So you, but you're very happy with where you are, so that when we get our first big international trial, you're ready to have Japanese sites in the international trial with so it's ready to go.
Yes,
Okay.
both face-to-face and telephone.
Okay.
Yes.
Wonderful. Thank you.
Thank you.
So I wanted to talk just a little bit about outcome measures for PLS clinical trials and to show you a little bit of work in progress that is still relatively small numbers. But we wanted to ask the question about which instruments can detect something that is clinically meaningful to a patient with a pure upper motor neuron syndrome. So we're looking at a combined PLS and HSP population, and at least for the PLS, this group is meeting the current research criteria of at least 4 years duration of a pure upper motor neuron syndrome. So I'll show you what you already know to start. So this is the ALS functional rating scale, and this is a small number. I'll just sort of draw your attention to it here. So this is from an ongoing study. It includes 10 HSP patients, 6 PLS patients, a total of 36 visits. And I'm going to restrict what I show you to those 36 visits because we have data on 3 different outcome measures. And these are assessments performed every 6 months. And we're looking back at the baseline assessment when people were enrolled in the study, and we're using a patient global impression of change on a Likert scale, a 7-point Likert scale, to ask, are you unchanged, are you a little bit worse, are you a little bit better, are you moderately worse, are you moderately better? You know the ALSFRS well, and if I show this to you here just to orient you, you can see that when people are unchanged based on their PGIC, if they're minimally worse, if they're very much worse, or very much worse, the ALSFRS is really insensitive to that. And what I'm showing you down below here, and I draw your attention to the mean scores, is you can see that, I'm not very good at this mouse, but these numbers really are not very different in terms of the mean change in the ALSFRS based on patients' subjective sense of how much they have changed or not. And so the ALSFRS would not be a good outcome measure in terms of quantifying something that's clinically meaningful to a patient. So I've drawn your attention to that. So what about the spastic paraplegia rating scale? That may be an instrument that this audience is less familiar with. I think this comes out of the HSP literature. So it's been developed for spastic paraplegia. It includes 13 items. Each is scored 0 to 4 for a total score of 52. It's looking at mobility, spasticity, weakness, contractures, pain, bowel, and bladder function. It's got good construct validity, good internal validity, good inter-rater agreement. There really are no floor or ceiling effects. And so what does this look like? This begins to detect a little bit of a change. So if you look down at the bottom there for the people who are minimally worse, it's about a 3-point change. That's not very different from people who report no change. Once you start to get to much worse, now they're close to 5 points, and very much worse, closer to 9 points. So beginning maybe to be able to quantify something that's clinically meaningful to patients with this syndrome. So what about then people looking at this patient-reported outcome that we've been developing called the ALS Health Index? So this is a patient-reported outcome. It was developed amongst patients with ALS and related motor neuron disorders, so included people with PLS and PMA. This has 15 items, and it gives you a score up to 100. And I've listed here the 15, 16 elements that this captures in terms of mobility, arm function, hand, finger function, leg function. You can read those yourselves. It's got good construct validity, good internal validity for all of the individual components. The inter-rater agreement is high, and again, it has no floor or ceiling effects. So here's what the data look like, maybe a little bit more promising. So the no change and the minimally improved now are very much the same. Once you get to minimally worse, you've got about a 3.5 point change. Much worse, almost 6 points, and very much worse, 21 points. And so unfortunately, we don't have PLSFRS data, which would be helpful to compare. But I think in addition to our looking at longitudinal change and variability, we want to, I think, do a better job, which we've not done so well with the ALS-FRSR, is asking patients what matters to them in terms of meaningful change, and then benchmarking our outcomes against that. And so I will stop there.
My question to you, Michael, the ALS high, is it built on the guidelines for building a patient-reported outcome? Is that the concept? Because I think that is, our ALS-FRSR was built in a completely different way than the current guidelines. So
correct. So
tell us a little bit more about that.
So it's built according to the current FDA guidance for development of patient-reported outcomes. We started with qualitative interviews, extracted themes, built an instrument, then went back to patients and sort of looked at how they respond to that cognitively, triaged out elements that were repetitive, ultimately built an instrument, looked at the test-retest reliability, and what we're now trying to do is to understand what's a minimal clinically important change in the instrument to be able to understand how we might power a trial around it. And it's really patient-reported. There's no administrator. Patients are simply asked to evaluate how they currently feel with respect to these functions. And so it's a point in time. It's not looking back over how does this change relative to before your ALS. It's how are you functioning now? And that now is not necessarily today, but it's presently. And so we can measure it at each time point and compare the change to a previous assessment.
Okay, so that's great. So you're obviously doing it in both PLS and in ALS. It was developed for both. Has it been used in adult onset SMA, or is it a completely different?
I'm not aware that it's been used in SMA, and it wasn't developed in a population with SMA.
Okay.
It was developed in sort of a broader view of ALS, PLS, PMA. There were some Kennedy patients included, but broadly, I don't think we had any adult onset SMA patients.
And has it been included yet in a trial?
I don't believe it has.
Okay.
I don't think so. I think, at least from my perspective, I would like to understand what a minimally clinically important change or difference is so that we would understand how to use it in a trial.
Okay. Oh, that's great. Thank you very much. Okay, I think next we're dealing with Dr. Turner.
Thank you. So the title given to me was, do we need to revise the current PLS diagnostic criteria? So the answer is no, but I think we should just sort of think, why am I so sure of that, really? It's about the problem that we kind of think we might need to solve. Just for the, as a reminder, I kind of thought that what we were trying to do with the new criteria were to be partly more inclusive for trials, to not make people wait for 4 years when we've already got an inclination that they have a slower progression, to provide some of the clarity in clinic that I think Chris McDermott alluded to, and to rehearse really all the evidence that we have, I think, to decide that a lot of the things that we were looking for were not going to be solvable by genetics, but to see where the place for that was. We heard very eloquently from John Fink about that and its role. EMG, and I think really where the limits really of that were, and not being over-reliant on that. So I think we sort of achieved all of those things, but what's the concern? Well, I think the concern, these are obvious things, but I think let's just be clear. Are we worried that people with PLS will miss out at an earlier stage of disability? Is that something that we're worried about? That's a sensitivity problem. Or are we worried about including some HSP patients or some people who convert unexpectedly 5, 6, 7 years? I don't think we can remove that risk. Is that what we're worried about? Or should we not be worried about any of those things, really? We've got a reasonably enriched population with these criteria. It's reasonably inclusive. I heard what Leonard said about going back to 1 year. I think that might be introduce an unreasonable amount of noise, but it's just arbitrary. So I don't think that I'm worried about sensitivity and specificity. We can't solve those 100%. Have they been validated? Well, this is just one study. You heard from Albert already, so it's a little bit redundant. What I took away from this, it is retrospective, so you know, we have to be careful with the V word, validation. That's quite a strong word. But what I took away from this, I was pleased to see, was nobody who was labelled definite went backwards and backwards into, no, we got that wrong. The problem is, of course, that there were people who didn't meet the criteria who then, with a bit more time, did, and people who, you know, who stick in the probable categories. So they're not perfect, but you know, I think the point is that it's doing what we kind of wanted it to do when we met last time. And lastly, I did a survey of everyone here. Thank you to the 23 people who replied. So I initially just screened people whether they diagnosed PLS, because obviously there are other stakeholders here, but we were after really thinking about the criteria and who uses them. So 19 people. Do you use them? 18 people did. I won't try and find out who the one person is who doesn't. But so 18 people use them. Do you request genetic screening on those you suspect have PLS? So 11 people always, occasionally. No one said that they never do. Do they need to be revised? 14, I think a reasonable majority said no, but the 5 who said they did, their comments are as follows. So TMS was one suggestion, really, and how we'd integrate that. I think with all these things, my view would be, you know, if we're going to put something in diagnostic criteria, everyone has to do it. And so we have to be very sure that TMS is solving the problem. So what's the problem that's trying to solve? Is it, again, sensitivity or specificity? Introducing NFL, I mean, I haven't piped up about that so far, but I'm, you know, I spend my whole life thinking about NFL. I'm not persuaded it has a value here, in getting more people in or making it more specific. But these are just my views, open for discussion. And then enriching with imaging, where we had a brilliant talk from Peter. And, you know, Peter's worked really hard at this, and I think it's telling us something, that he's not able to get that over the line. It's not lack of data, and it's certainly not lack of skill or thinking outside the box. So, you know, I don't think I can think of an imaging thing that everyone would suddenly have to do that would be realistic. EMG criteria, it's not my area of expertise, but I guess the issue is really, do you need to loosen that so we're not striking people out simply because they've got some EMG changes? I do worry about that. Conversely, we heard about some cases who changed the view, you know, 5, 6 years later. Do we need to be more open to doing it more regularly? I had an interesting discussion with someone over tea about that. You know, that upsets people, upsets patients if you start making EMG the arbiter of everything. And taking away people's labels is not, you know, this is about science, but it's also about the real world of the clinic. And giving people labels, we need to be very clear if we're going to say, but at any moment we could use EMG to take that away from you. It has to be about more, to me, more than just simply EMG criteria. New diagnostic tests to be included, yeah, but I don't think we've heard any diagnostic tests today. So that's it.
The issue of the label, what did you mean by that? Taking away someone's
label? So I think I'm conscious in clinic that people, we shouldn't underestimate that for many people that I see who are living with PLS, that journey to that label and its uncertainty and, you know, when it's then later threatened in the sense of actually I'm not sure if it's PLS anymore, it has surprised me in the past how much that is important to people. It sounds obvious, but yeah. we need to be quite careful about, in our wish to be inclusive, if we're then going to be less flexible later on and say, but, you know, if the EMG changes, then that's it. It's changed again. So I think labels are important to people. And I'd rather we kept in the uncertainty bracket of probable than we tried to be much more specific early on and then changed our mind, because I think that's very disruptive to people.
And you're really talking about changing it to ALS.
Yeah.
Okay.
I mean, the facts are the facts, but if we've implied that we can be very certain early on, we better be very clear that we can be. And if we can't be, we should be honest about that and say, you know what, with the greatest minds in the room, it is still not possible to guarantee anything. And we have to be honest about that.
Great. Okay, I think, thank you. Okay. Thank you, Martin. I think we're turning to Dr. Corsia, who is going to give the entire talk in French, no?
Yes, if you want. So merci de m'avoir invité. Thank you, Hiroshi, for the invitation. I'm one of the last to speak now, and the majority of things has already been said. So to find a clinical issue after all this presentation is a bit difficult. And I focus this presentation on 2 points. The use of the PLSFRS, and for this we need to harmonize our practice, and we have to validate PLSFRS scale in our own language. So for that time, there are only 2 PLSFRS scale validated in specific language, in English and Japanese. In progress, we have a French version, which is supposed to start in early 2025. It is the same for the Swedish, Italian, and probably the Dutch cohort with a specific version of the PLSFRS. And the second point is, how long do we imagine to have a clinical trial in PLS? As you know, the PLS has a long duration, and I think it's very difficult to imagine a trial over 18 or 24 months. So is it possible to imagine to have a trial in PLS on a shorter duration? There is a nice, of course, paper from Hiroshi and his team on the PLSFRS, and the study proved that there is a significant difference in the PLSFRS score at baseline compared to week 24 and week 48, excuse me. So the PLSFRS reveals significant change over the time interval as short as 6 months, suggesting that clinical trial with a duration of 6 to 10 months should be sufficient to observe a demonstrable difference. So it might be probably possible to imagine to conduct a trial in PLS over 6 to 10 months and to have a significant effect on the drug on this short period. So thank you very much for listening to me for this.
Thank you, Philippe. So what is the length of time that we can tolerate for a placebo-controlled trial in PLS?
Oh, it's a big question. The problem of the placebo control is also an issue we can discuss. Is it possible to have a trial without or with a control group? I think that a trial with a duration of 10 months would be reasonable to detect an effect of a drug in PLS.
So what of our primary outcome measures are going to detect a change, clinically meaningful, using Michael's expression? What do you think? Because I'm just imagining this PLS may be a good time to event. Time to event may be a good option, but still, what would we use? What are you expecting?
Yes, for me, one parameter could be the slope of progression of the PLSFRS over the duration of the disease, of course. But I think that the PLSFRS might be a good tool to evaluate a therapeutic effect in PLS, even on a short period of 6 to 10 months.
So in a completely different disease, and I know it's like completely different, myasthenia gravis. We have a physician-reported outcome measure and a patient-reported outcome measure that we use. Is it time to start thinking about our PROs as potentially primary in a disorder like PLS, or are we still too nervous about what the patients will do?
I think it's too early to imagine such a parameter for evaluate a drug in PLS. We don't have any trial in the background. So we have to conduct the first trial with some simple parameters to imagine to detect an effect. And with time, if PLSFRS doesn't prove its relevance in trial, maybe we can add or change the endpoint of the trial.
Okay, great. Thank you. Senda?
I think we have a very difficult challenge. PLS is unique in the fact that disease-modifying therapy and disease and symptomatic treatment is going to be overlapped as we develop those outcome measures. It's going to be very difficult to say if we're actually affecting disease progression or just resolving symptom, like take spasticity, for example. So that's going to add another level of difficulty for trials.
But do you think it matters to the patient if they are feeling better, if they're functioning better? Does it matter?
Yeah. No, I don't think so.
Okay, that's fair. Okay, people can challenge me after. Vincenzo, your turn. You're the last one.
So I'm the last one to ask, what else? First of all, I think we have to keep in mind this is an ultra-rare disease. So in order to design a trial, I think we have to be bi, tri, or quadricontinental, just to share the same, the ultra-rare patients. Well, related to collection of patients, actually we have the guidelines, we have a criteria, as Martin expressed, that has been validated. So we have criteria to at least select our patients, but I personally think we must be ready to be more sophisticated. Like in ALS, probably we have to analyze our patient according to motor function, cognitive behavioral function, extrapyramidal function, and something else. So everything, I think, in my mind is getting more complex. I personally think that we are avoiding one of the major issues, namely the contribution of TMS motor evoked potential in definition eventually of a disease. And I was the first one that Martin showed on the top saying that I think we have to face the issue and make a conclusion if we can learn something or we can use somehow neurophysiology of the cortical spinal system as a biomarker. Furthermore, we learn about neuroradiology. We don't have a biomarker. I'm personally very convinced about the band that has been expressed. The SVI, actually we use, and we are totally convinced that the value of the SVI is different in PLS according to ALS. So it's a good marker of accumulation in the cortex. And actually, I personally think of it as not just a diagnostic biomarker, but also related to the pathogenesis, because as has been said, probably iron is accumulated in microglial cells. You know the microglial cells are very important in the pathogenesis of the disease. What about biomarkers in the plasma? I think if we are learning the lesson from Tofferson and other trial, we have to use NFL right now, even if we must be open to other biomarkers. What about genetics? Actually, we don't know anything about genetics of PLS. We know that we have to check for C9 for some patient. Obviously, if we have doubt, we have to check our patient for all the targets for SHP. What about common outcome? Well, we have a function, obviously the PLS function rating scale, and this is very important, but this is a motor scale, never forget about that. And obviously we have to add some other subscale that we can use, and eventually we have to add a quality of life scale in order to run our biomarker, and obviously we need to complement all those information with a biomarker collection neurofilament problem. What about the timing of a trial? This is a major question. Albert mentioned this morning L-DOPA. I used to treat PLS patients with L-DOPA, and actually they answered this is a symptomatic treatment because we have to divide the symptomatic from non-symptomatic, and the answer to PLS is usually few weeks. But obviously, if we are thinking in treating the disease, probably we are facing few months or 12 months. I have no idea right now. And probably we can use artificial intelligence and all the details related to make a prognostic model of the disease. What about attracting company? I don't want to use a bad word, but I think the PLS is an aborted ALS. This is very intriguing in terms of biology. And I remember Iko Brack tried to dissect why the lower motor neuron are surviving when upper motor neuron are surviving. But company can be attracted by this message. Obviously, we have to consider disease modifying versus symptomatic treatment, two different stories, I think. But we have a possibility to act on spasticity, act to have different component of a disease, and probably we have to consider real-world trials as well at this event.
Fantastic. So, good. A question. Hi, Leonard.
Hi, Angela. Can I ask a question?
Yeah, you can ask.
Yeah, okay, Martin. Yeah, you're in the panel, are you?
Yeah, you're on the panel.
Yeah, you're on the panel.
You have to come and sit.
So, about the criteria. So, the probable PLS thing, you don't use in clinic then? The probable PLS you don't use in clinic because you don't tell a patient you have probable PLS, do you? Because you rather keep them in uncertainty. I agree.
Yeah, I do use that.
Oh, you do use it. Yeah. So what do you tell the patient? Because you prefer to leave them in uncertainty, as I understood.
No, I didn't explain it very well.
Because there's a large chance that it will change to ALS.
My concern is if we start making EMG a mandatory requirement that's done regularly, that goes past 4 years, we need to be very careful about that. I didn't make that very clear. That's what I'm worried about. That we start, that would be quite a departure really to start actively looking for that sort of EMG change.
Yeah, so
I do say people have probable PLS, but I explain what I mean by that. And actually, I have a discussion about, that nothing magical happens at 4 years, but statistically, we then are in a much stronger position.
Yeah,
but
it's
never 100%.
Yeah. I wonder whether we have to use it more as a research criteria.
Well, I mean, my big driver for the Gold Coast change, the only thing I wanted to see achieved by those criteria was that we dropped possible, probable and definite ALS, because they're deeply unhelpful terms in the clinic.
Yeah.
And most people, if they've got anything other than definite ALS, will ask to see another neurologist who can tell them what they've got. But I think in PLS, it's a different problem. And I think we discussed this, didn't we, sort of 5 years ago, that you're acknowledging that PLS is a possibility, and I think therefore it's reasonable to use the word probable or possible. We talked about that. So I don't have an issue with that, as long as people understand that there is still uncertainty. Whereas I felt the Gold Coast was about saying you've got ALS, you haven't got ALS. It's totally the other way around.
Yeah, because I had a patient, I think a few weeks ago, no, a long time ago, but the patient was talking to our patient organization, and he told me I was referred as having ALS, because they come to ALS clinic, and I explained very carefully, you just have open motor neuron features, now it's not, the whole story, but they don't listen always so well, because they hear, oh, it's not ALS.
No, they're Dutch.
No. No, they hear, or yeah, it could be. But don't you, yeah, okay. They're Dutch, that's right. Yeah, you're correct. But, so they kind of, they don't hear it's not ALS. So, yeah, okay, that's difficult. So do you think we could design a trial where we don't look, where we could actually, the outcome, the primary endpoint would be how we can prevent lower motor neuron loss. So that you actually prevent the patients to go into, the diagnosis will be changed to ALS. So you would include them very early, just upper motor, and then, do you think that's realistic?
So that's time to event.
Yeah, time to event, yeah.
I think that's a really, yes, I think that it would be a super interesting concept to explore. Yeah, because then you could include them very early.
Yeah.
After you do their genetics, of course, Matt.
Yeah.
We always do our genetics before we do anything else.
Yeah.
Good idea.
Okay, thanks.
Hiroshi.
This is a really great discussion. Thank you so much. I have a question about diagnosis. As you heard, we included early PLS, even before we didn't call possible, but early, because obviously you saw so-called early ALS declined rapidly. Yet surprisingly, they did not become so-called upper motor neuron ALS type based on EMG. So that's one question. Martin, what do you think about this, including early case? That's what I think is very important, because any neurodegenerative disease, I think, is eventually we have to pay attention to make a diagnosis early, because if you make a diagnosis late, all neurons are gone. So that's the reason I'd like to tackle early stage.
So who's answering? Martin?
Yes.
You lean forward first.
But I was just checking. My first question is I don't think we've seen the data today, the real world data. How many people come to a specialized neurologist before 2 years? It's not many. So let's not over worry about that until we see the data that that's a problem we need to solve. The game changer in the last 5 minutes is Leonard's suggestion of time to event. I think that's...
Yes. I said it first. I'm just letting you know that.
Yeah. I think that just needs... Yeah, I'd need to let that sort of ferment. But that would be then, we could say, yes, so we're not worried. But personally, I don't think there's many people in the PLS phenotype who get to specialized neurologists who see a lot of these conditions. There's not many of those people who come significantly before 2 years, would be my guess, but I haven't seen the data.
Michael wants to make
sorry, I just wanted to comment on the notion of a time to event of developing lower motor neuron dysfunction. If we think that's an uncommon event in the population that we're trying to select as having PLS, that's going to be a very challenging trial to power, because the power will come from event rates. And after all, we're trying to think of paradigms to treat ALS, not lower motor neuron forms of ALS. I don't know, it feels like it's the wrong time to event. I mean, I think the idea makes sense, but I'm not sure that's the right event.
Primary outcome, the right event to follow. Okay, that's fair. Hiroshi, it's your meeting. You get to ask another one.
You have some answer?
After.
Go ahead.
The problem with early PLS is the absence of diagnostic biomarkers, so you don't really know what you include in the early PLS, even only after a time of follow-up, you can be sure that the patient has really a PLS and not another autoimmune disease. So if you include early PLS, you might include patients with other disease than PLS, so it might bias your trial. No?
So probably, Russia, you can use as a secondary endpoint this conversion, but I don't think it can be used as a primary endpoint.
So I have a second question, sorry. Again, Martin, you mentioned about EMG. You're concerned about the use of EMG, but I think to me, EMG is such an important tool to detect lower motor neuron, obviously. So still I think it's time to event or whatever. I think EMG would be extremely important tool.
Yeah, again, I'm interested to know from colleagues who are seeing a lot of patients what makes them do another EMG. I don't think we've heard that today. You know, and if it's because someone's developed a new symptom that's made you suspicious, then that's understandable. If it's just to check that there's still nothing there, I think that is, we need to be very careful about, you know, why we're doing that really. So it's an essential tool. I mean, it's absolutely essential in that early phase. It's really what happens after 4 years. It might be that we have to, you know, make an argument for an annual assessment, but we need to think very hard about that and whether there's evidence for that.
And Martin, I think the patients are the driving force for doing repeat EMGs. The anxiety, I've educated them. We have this arbitrary 4 or 5 years. I say make it 8 or 10. In my opinion, they're the driving force.
Yeah.
And particularly if they also say, I want to be in a drug trial. I want anything I can do to participate in an ALS drug trial. So most of my patients are going to have a repeat EMG in those first 4 or 5 years, every 6 to 12 months.
Yeah, that's really interesting. I hadn't thought about the angle really on access to trials. And again, it's an obvious thing, but I do think it will be important at some point that the patient community, people living with PLS, you know, get to decide really what the outcome measure is that they would prefer. You know, you know, a lot of that's been done, that work by Hiroshi, with focus groups involving patients. But I mean, we should be very clear that we need to kind of understand what the outcome, the preferred outcome measure is.
Well, in our experience, we have two kinds of population. We have a population we have to follow in the first 3, 4, 5 years, and then became stable as a PLS. At that point, you don't need to repeat EMG, because they remain very stable.
So Wendy, you've been patient. Go for it.
I feel like I want to have a discussion about everything else that's been brought up before. So what Martin was talking about, it reminds me of ocular myasthenia versus generalized, right? How do you have that conversation with an ocular myasthenic? The difference, of course, is that we change the course of myasthenia when we treat them. We don't have that luxury. Right. So what actually brought me to the microphone, these many minutes ago, was what's the difference between real-world evidence and pragmatic trials? Because I think my understanding is pragmatic trials are more systematic. There's ground rules, but you are using existing strategies. And so to me, looking at all the slides that have come up, chemodenervation has been touted as a therapy for PLS. We're basically seeking to denervate people with a motor neuron disease for symptomatic benefit. So to me, if we could just organize everyone and do a pragmatic trial to say, let's all have the same criteria for when we do chemodenervation, and let's see if that changes the natural history one way or the other. Because at least there'd be a symptomatic benefit or symptomatic outcome, at least a conclusion there. So real world evidence to me is kind of passive, whereas pragmatic trials, as I understand them, are a little more active, use existing knowledge and therapies for new discovery. So a comment from the panel around pragmatic trials versus real world evidence versus standard clinical trials for drugs that we don't even know about yet.
So Sandra, what do you think?
I don't have a personal vision on that.
Pardon?
I don't have a personal answer to this.
You don't. Sandra? So Michael has a comment? Good. Okay.
Well, since we keep raising myasthenia, I was just going to sort of think about a parallel here to real-world evidence. We've had a large initiative in the myasthenia community with the PCORI initiative to understand the relative utility of azathioprine and mycophenolate in steroid reduction and improving outcome measures in myasthenia gravis. And this adopted the real-world evidence approach of letting physicians prescribe what they want to prescribe and gathering the data and then trying to look at it. And the concern I have is that the conclusions that have been drawn from that study go well beyond what the evidence provides.
Okay.
So the conclusion that's been drawn is that these two drugs are probably both equally effective, and that maybe we don't need to use them for as long as we think, or in the doses that we think, because patients seem to benefit. And the problem is that in myasthenia, there's lots of background therapy. People get steroids, they get other treatments, and so you can't actually draw those conclusions that you can use a lower dose or for a shorter period of time, because you're not isolating what the thing is that you're studying. And so I guess I'd be open to the idea, but I'd love to hear sort of the pragmatic nitty-gritty of how we would actually get real-world evidence and isolate the treatment intervention that we're interested in. And in a heterogeneous disease with heterogeneous practice of what people are doing, I don't know that that leads us to evidence, but maybe people in the group can think of examples from other diseases where real-world evidence has led the way in teaching us something about what works and what doesn't. But I'm drawing a little bit of a blank. I'm not. I was just giving an example from real-world evidence of how underwhelmed I am by how it can help us inform practice.
That's why I think organizing into pragmatic trials could be more efficacious than this so-called real-world evidence.
Yeah, you may well be right, and I'll let somebody else comment on that. I think I have less experience with a pragmatic clinical trial.
So I'm going to keep people moving, and Matt.
This will be very brief.
Okay.
The bringing up chemo deinnervation, the idea that we do have multiple drugs that different people use in different ratios and preferentially for the extrapyramidal, the spasticity or rigidity. How are you envisioning, kind of this very small population already with various, like I know we're standardizing the PLSFRS, but are we also going to standardize the approach to spasticity in the way that myasthenia gravis trials standardize the approach to prednisone use and peeling back on prednisone, and we should be thinking about how we're going to harmonize that as long as we're thinking about harmonizing across 4 different continents.
No, that's absolutely true. How to manage a standard of care interventions. Yeah, I think we might need another meeting, Hiroshi.
Yeah,
I'm just letting you know.
A meeting on standard of care for PLS.
Yeah, there you go. Go ahead, Martin.
Yeah, I do think it's a priority that we improve how we measure spasticity, and I think there should be funding for projects that want to try and quantify that, because that's going to be a very key measure that we want to sensitively change and get an early readout that we're changing. There's all sorts of really amazing people doing some amazing things in muscle, looking at metrics there. So I think defining quantitative markers of spasticity is a key thing in this population.
Great. I would agree completely with you. We're still using physio scoring from 40 years ago. So
Ashworth's not going to cut it.
Ashworth is not going to give us a new therapy. Yeah, what Grace presented. Yes, absolutely. Okay, Mamid, and then back over here.
Okay, thank you. So 2 or 3 very quick points. I mean, regarding the spasticity, we have a number of neurophysiological methods behind TMS, like age reflexes, and that we can use and quantify the promoter neuron involvement that could be explored in PLS. Regarding the EMG, I agree with Martin Turner. But anyhow, I have patients that ask me to perform EMG because they want to be relieved from ALS. So it's a psychological approach, and I should accept, otherwise they will think that I'm trying to avoid any error that I could have made in the diagnosis. So, I accept and I repeat. Another thing, and final one for me, is that we need in PLS to define time to event in trials, like, for example, losing a capacity, like walking, or spreading of the disease, going to upper limbs or bulbar region. If you use time to event, it can be useful, because then we will slow disease progression. Thank you.
Thanks, Mamit. Dr. Yes.
Hi, I just have a question, because we had 4 patients in our at Cedars that participate in the trial. They know I'm here and they're going to ask, right? So what's holding us? And so looking at the data, it looks like the definite group might be a problem in terms of some of the outcome measures, because it might take too long. But the early and probable look like there's significant changes, even as early perhaps as 6 months. So what's really holding us from including these patients in ALS clinical trials, the early and probable? Why not go include them and then have the PLSFRS and those outcome measures that we did?
I think that's the debate we're hearing. So you're on the early diagnosis, early intervention side.
Yeah. I don't think it will make a difference, right?
Okay.
They are in an ALS trial, as long as we include some of the ALS-specific measures as well.
Perfect. Okay, Dr. Fink,
Yes.
it is totally appropriate that you were first and last in today's panel, so I'm giving you the last word.
Thank you
and
very
then
much.
Sabrina.
I appreciate that honor. I never want to be in a position to disagree with Martin, but I have to. I don't like to use, I'm going to argue against measuring spasticity as an outcome parameter for 2 reasons. One, it's highly variable, depends on weather, sitting, stress, sleep, medication. It varies day to day. Serial measurements, the Ashworth scale, 2 weeks apart, quite variable. So I think it's not reliable. Second, spasticity can change even though the underlying condition may be static. I'm thinking about after stroke, after spinal cord injury, where there's no, spinal cord injury, spasticity emerges over a period of time, even though the condition itself is non-progressive. So I just would argue against measuring spasticity in our current way we do. If you have some electrophysiologic way or a better way to measure disinhibition, I'm all for it. But the hands-on approach, I would argue instead of that, as was just mentioned, a functional outcome or foot tapping. I think foot tapping is a very superior way of measuring distal speed and precision of upper motor neuron problems, which is the hallmark of upper motor neuron problems, the distal speed. And so I would argue functional rather than spasticity.
Thank you. And for somebody has a comment. I nearly closed up.
Sorry, Angela. I guess, Dr. Fink, I just want to sort of push back a little because I'm thinking from the FDA's perspective, and I can't comment on the European Medicines Agency or other regulatory authorities, but they want to know they want outcomes to reflect how patients feel or function. And foot tapping doesn't tell us that. And so it may be a nice quantitative measure, it reflects what we're after, but I guess I would discourage us as a community from pursuing that, at least as a primary outcome measure in a trial. I would very much favor global functional measures, whether it's an administrator interviewed or a patient-reported outcome. I just think we're going to get more mileage out of them.
I agree. Functional outcome is a superior.
Yeah.
So with that, I want you to give another round of applause to this great group.
Thank you so much. We are in the home stretch, so we have about 30 minutes before the end. The next panel is going to be without slides, which I'm sure everyone is excited about. I'm going to be moderating, and the moderators from the previous panels, if they can come up. So what we wanted to do, because we don't get together often. The last conference was 5 years ago. So we really wanted this conference to be sort of action-oriented. So hopefully we'll have some take-home points here. So I'm going to ask 2 questions to every previous moderator or panelist here. I would like to know from each of you the one take-home point or highlight from your panel. What is it that you are taking home with you from the discussion in your panel? And the second and most important question is, we are all going to go back home on Sunday. What should we do next week, starting next week, together in groups, internationally or in, the single institutions to take the next critical steps? So I'm going to start, I think, in order of panels, and you're first, Leonard. So your panel was about taking PLS diagnosis to the next level. So what's the take-home point, and what's the next step we should all be doing when we go home?
Well, I think the major thing is that we have not reached really consensus about the upper motor neuron syndrome or you have the purist, so the definite diagnosis of PLS, and then you have the patients who want, the people who want to include also patients that have upper motor neuron predominant ALS. Sorry, it's in the middle of the night for the Europeans. I think they're some sleeping in the back there. But yeah, do you
so
understand
what
I mean?
Yeah. So what should we do about this?
It's good to do more follow-up studies, I think, before we start trials to really
Like
get
natural
more
history?
for that natural history studies.
Okay.
Yeah.
And any other comments or?
I think
see
the
many
second,
people nodding.
is actually the symptomatic treatment. I really thought that that's also something we have to take into account, because if we do not have standard of care, then the outcome measures will be difficult.
So I see another vote of support for another conference,
Yeah.
Hiroshi, on symptomatic care and clinical care.
So obviously we don't have any medication to try. No. We don't, so many things, agreement and disagreement. So I think we have to find out how we work together. We did the United States, you did of course Netherlands, Ireland, and very beautifully individually. But still we have a problem to collect big number of patients. I think as just Leonard, you said, I think we need another practical, whatever the practical natural history studies. We have to establish how we work together.
Yeah.
How
So
we
if you
can
do that,
analyze together. That sort of thing is very important.
Yeah, so that also includes better to combine probably registries and stuff like that.
Yeah, I think, you know, we're talking a lot about diagnosis. I think when we talk about this, both the clinical care and standardization and clinical trials, we have to focus, I think, starting from the person living with the disease. And the SPF Foundation, way long time ago, we had a very small mini meeting. I think Dr. Fink was there. And we conducted a survey of patients through the SPF Foundation. It was a partnership actually through the Niels. So actually you were there too. And we had 220 some odd respondents who self-identified as HSP and PLS. I think 120 something was HSP and 72 PLS self-identified patients. And there was a series of questions, but the most important question actually relates to what Mike Benatar was talking about when we're looking at outcomes and what's important. The most bothersome symptom that was reported by PLS patients was walking and speech, not swallowing, but speech. And in HSP, more, not surprisingly, was walking. And so when we talk about clinical trials or finding therapies, whether it's to treat the disease, I think it's also equivalently important when we're trying to figure out how to run a trial or look for potential therapies to treat symptoms. The second is obviously standardizing care. In that survey, patients with PLS and HSP and related disorders were seen all over the place. Physiatrists, primary care, neurologists. Some didn't even go to a clinician because they felt like they did not have any point in going because nobody had anything to offer. So I think there's a few things in terms of diagnosis. Number one, I think if the SPF Foundation or other foundations could certify centers so that people with these disorders know where to go, that would help us kind of get to the patients, number one. Number two, obviously tightening up our diagnostic criteria. Maybe what we have now is good enough, but I think we could do better. Hiroshi's point about diagnosing earlier, so maybe using multimodal approach, so using all of the things that we saw, the MRI imaging, the neurophysiology, plus our clinical exam, and maybe the scales to kind of come to a diagnosis earlier could be an approach, a multimodal approach. And the last is obviously, we may not have drugs to treat PLS, but we definitely have symptomatic treatments that we could probably use and test and then develop standardized guidelines.
Yeah, well done, Gingy.
I got you.
Yeah. So, and the population could also be different depending on the question you ask in the trial, in the study. So if you do early patients, you could do time to event. If you just want to treat the upper motor neuron, you may go for, it's better to go for the definite diagnosis of PLS.
So that ties in, it's really connected to the second panel, Matthew. The title
The
of
other
your...
thing I thought was very nice about John Fink
Yes.
was actually that if you have bulbar symptoms, it can't be HSP. Sometimes that's debated, but now I believe it. I think that's good. Sorry.
So your panel was about global registries, or kind of ties into Please, what do you think? What's the take-home point, and what can we do next
Well,
week?
I think Hiroshi sort of covered it, but I suppose in the second session it was relatively uncontroversial, and it was amazing the uniformity from the Irish registry to the Japanese registry to the NCAL's PLS to the international expansion and the CDC. They're actually just saying the same things over and over again. The missing link, I suppose, is what you're saying, Hiroshi, is to link them in some meaningful fashion. It doesn't need to be a lot. It could be just one or two clear sort of, to bring it all together. Then I don't think we'd need them. I mean, we've got so much natural history already. And just to reinforce the point that was made, or points made about treatment, I mean, we have successful treatments, particularly things like botulinum toxin. The spasticity is progressive. Can we use some of these sort of measures for you know, moving the field forward in a positive way, in a therapeutic fashion, and whether that will actually alter some of the course as well? I mean, again, it depends on what we're measuring.
Alex Sherman.
Alex, come to the mic.
So I have a question. He mentioned there's a tremendous barrier, European Union and other countries, to share the data. I don't know detail, but we have to solve how we can share the data if we do multinational, multi-continental studies. I think that's crucial.
You shouldn't have voted for Trump.
I'm not going to repeat it. Once is enough.
Well, it was referring to, I think Hiroshi was referring to GDPR and other data protection laws, actually.
So we have difficulty in Europe sharing outside of Europe. It is possible, but we need, the consent process is different.
Right.
And there are lots of legal barriers to us doing that. So that is a problem for us because...
to be in one database.
Yeah, the data protection is different in the US.
I think this is data
and
protection.
it may be problematic with the
So GDPR is very doable and workable. I think that sometimes our European investigating friends are using GDPR as protecting their data rather than their patients' data. So that's my, I don't know whether Orla understands me. My accent, but
so GDPR.
I'm saying that you're not sharing data as broadly as you can.
GDPR
based on GDPR
is real, alive, and lives in Europe, and it's problematic because of the legislation. It's also different centres in Europe interpret differently, different countries interpret differently, different hospitals interpret differently. In order for us to be able to share, we would have to consent patients for a much wider set of data sharing, and that can be problematic under GDPR. So it is problematic. It's not straightforward.
But Orla, you've been successful, right? You are doing studies multinationally, right? So
no, the study, Precision ALS is Europe-based, and we spent 2 years working through the GDPR. It's coming out. It's coming out in the journal quite soon. The process by which we do this. We have a lawyer, which we have on standby. We meet with the lawyer every week. She's from the Netherlands.
Yeah, we succeeded.
Yeah, well, I mean, we have a very good data collection process in Europe, but there are issues about data sharing outside of Europe. It's possible, but they're problematic.
But it was also relatively
correct.
So to Matthew's point, I mean, we have the representatives of all groups here. So how can we, you said, I believe you said the problem is linking all these registries. So how can we do that? We have all the representatives here.
We can link and harmonize. So we talked about this morning with Bob Bowser, and we had representatives from all ALS at our precision meeting. So we can harmonize. We don't necessarily have to share everything, as long as we're doing the same thing across different sites.
Makes sense. Yeah. Alex?
Thank you, Sabrina. So basically, so David Walk here and I, we're running an ALS MNT consortium, as I was showing, 2,800 patients, 11 sites, 2 of which are European sites. And we successfully negotiated GDPR clauses in our contracts with those sites. Moreover, pseudo anonymized data sets, according to GDPR, are excluded from GDPR. And
no, that's
well,
not
I mean,
entirely
I don't
correct.
want to go too technical, Orla. I'm
So
saying
that is not entirely correct, Alex. It's not as simple as you say. And pseudonymized is considered still data that is identifiable. So identifiable data is still problematic.
Okay. So what actually Matthew suggested this in our pre-discussion before this meeting is that if we can harmonize what we're collecting in terms of the data, if we can talk to each other and see what's possible. So right now, the US shares data quite broadly. You know, all ALS data will be shared. The MND Natural History Consortium 2000 plus, again, is being shared as asked. PROACT is being shared. So I don't see any of the Europeans contributing to PROACT, for example, while you're publishing probably monthly on PROACT's data. So I don't see any Europeans sharing any natural histories data. So even before GDPR, but currently with GDPR. So my point is that at a minimum, we can harmonize, we can agree what's necessary to put into our ICF language to be shared when investigators decide to share. So because otherwise, if you say, oh, only for research for NCALs, only for research in Dublin, that means that it will not be or it couldn't be shared 10 years after you decide to share. So my point is right now it's worthy for us to sit down and agree on what's necessary to be shared, if we decide to work together in the future. And it's easy. It's been done in other diseases and it's been done across multiple initiatives here. So I don't believe we can stumble on this.
So to keep moving, I think what we're hearing is that there is interest in harmonizing what's collected. So just to keep going through the different panels, Orla, you also moderated a panel on biomarkers. So what biomarkers should we collect, or should we just collect biosamples, I guess?
I think the biomarker section was very interesting. So I think we need to be clear about what we're talking about. Are we talking about diagnostic markers, discriminatory markers, pharmacodynamic markers, prognostic markers? So we had a bit of discussion about that. So there was 3 wet biomarkers, microRNA, lipidomics, and serpins, which sounded very, very interesting, possibly discriminatory between ALS and PLS. And then we had 2 markers which were based on imaging and neurophysiology, which have a potential for as discriminatory, diagnostic discriminatory. So I think there's a lot to be talked about, particularly in the wet biomarker space, and some of these wet biomarkers could be useful both in discriminating between ALS and PLS, but also as markers of pharmacodynamic markers if we were to have a drug that was useful from a therapeutic disease-modifying point of view. But I still think we're a long way, and I agree that we should be looking at symptomatic treatments before we start looking at disease-modifying therapies at the moment.
The other biomarker we didn't talk about was digital markers, so we're like clinical markers, right? So not necessarily wet biomarkers or neuroimaging, but use of, for example, if speech is, so speech technology that we're already using in ALS, we can leverage into PLS and maybe a sensitive marker of disease progression to look at articulation, or looking at wearables and distance walked, or the stride length. So I've done that in other diseases. Or there's now these devices that you can put in the shoes. And I've done this with physical therapists for some of the muscular dystrophies where they walk, and we can measure stride length distance all together, and it's a very simple device you just put in their shoe.
So we have this morning.
Yeah, here you go.
We discussed this in Precision LS this morning. So we have one of the work packages in Precision LS is looking at all of those and testing both the utility, the feasibility, and the acceptance of some of these markers. And they might be more useful in PLS actually, because the disease is more slowly progressive. In ALS, there's a big attrition rate in many of these technologies.
Angela, has a comment?
So in CAPTURE, which is the Canadian Longitudinal Project, we actually have a sub-study using the INSOL technology. And that data set will be 4 visits over 12 months, every 4 months. And the first round is done, so we're looking at 2.0. But we have imaging, we have all of the different outcome measures. That's an ALS study, predominantly, but we have PLS normal controls in that project. So that's definitely one of the most interesting things. And the other thing that's coming out, again, through both the neurodegen and neuromuscular drug development spheres, are motion detectors. And one of the current studies in ALS, which was pulled from, this technology was pulled from, I think, DMD, Duchenne, is the Emerald technology, which is a motion detector. So we've got a long way to go with that. I think there are lots of opportunities with those things.
So there's a very nice technology that we're using called Gatekeeper, which is looking at gait. It's developed by physios. It's really useful as well.
So it seems to me that there is already some work towards harmonization. I mean, you spoke about precision and all ALS as 2 examples. You just mentioned the Canadian group, CREATE will be another big study. So I wonder, is there a possibility maybe of leveraging that type of work and infrastructure and harmonization that's already happening for ALS, for PLS actually?
I think it's critical. I think it's critical. It's already happening. We should not make it more complicated than it needs to be. Let's use what we've already harmonized on and just apply it to our biggest risk is reinventing the wheel and making it more complicated. Let's keep it simple. Yeah. The first time I heard Alex talk about harmonization was somewhere around 1995. So I think it was 95. It's the first thing he ever said to me, harmonization. He said a lot of other things, but he did say, that's probably it. But we're limping towards it rather than speeding towards it. We just got to solve it, get over ourselves.
So it seems like there is some progress. There's some ideas out there. Now, the next panel, actually, Mahmoud, your panel was about PLS-specific outcomes, though. So I agree with you, Angela, that there's already things that we have. But should we add, what's your take-home point, Mahmoud, from your panel? I mean, what scale or kind of outcome metric should be included maybe in these efforts for PLS in particular?
Okay, thank you. I mean, really, I mean, I think the scale is working well. I mean, I would like to remember when first trial, because it's about trials in PLS. And so when first trial in Ludolph was done, there were no criteria. No good clinical scale, because they used the Norris scale, which are not very good. PLSFRS was not born yet. And so they had a time of event was death. And so we have time of event in PLS, we mentioned that, stop walking or not speaking so well and so on. We have spreading, which is a new concept. Spreading was not popular at that time. And we have a very detailed scale, which is more detailed than the LSFRS. And this seems to be reliable. Many countries are validating it. I mean, at the time of Norris scales, there were no concept about validation. It's something that was not used. And so we have that scale now, and it has been validated in other countries. Some more work is being done. And so I think we have enough tools. I mean, if you want to start a trial, if you want. I mean, of course, there are much more things to do, but every year we have a meeting on ALS because we think there are more things to do. And we have done more than 300 trials in ALS. So, I mean, we have enough to start a trial in PLS. We have enough things, I mean, enough tools, clinical tools in particular. People are used to them. We need to improve. We have to quantify more. For example, we learn, we know that, I mean, that spasticity is quite variable. I mean, and you would like to, for example, to test dopamine or other treatments on spasticity, but clinically it's difficult to evaluate it. So we have the tapping is a way to quantify, and you can develop or apply very well-known neurophysiological techniques for this. Very simple, not complicated. MRI is okay, but it's very expensive, and if you include many centers, it would be difficult to have great expertise and money for MRI in many, many different centers. And so we have enough, and I think we learned that we can be confident that that scale is useful for PLS.
Great. So actually, I want to follow up on something you said. We meet every year for ALS, and we have had many trials. Now, we have met 3 times, thanks to Hiroshi, but that was over the last 20 years, right? The last PLS conference was 5 years ago. So should we meet more often for PLS?
I mean, I think we are prepared. We have enough tools, but maybe we don't have the right drug, and you don't have the right company for paying the trial. That's another point. But I think we have enough information to try one. Yeah.
Angela, any comments?
Is it my turn?
Go ahead. So, yeah, what do we need next? Your panel was
So I just want to point out that I had a fabulous panel.
Yes.
Okay. Very smart people on my panel. So they all had good ideas. So what's next? I think I have 2 or 3 cautionary tales. Not cautionary tales, but maybe a bit provoking. Just because we look at PLS and ALS as very similar doesn't mean that our trials designs need to be the same. We need to think about, and I'm very curious about the high results, the ALS high results in the PLS patients, and Grace's finger and toe tapping. We need to look beyond what we do in ALS to other innovative trial designs to see what we should be pulling in. I think that's really important because we're used to doing things a certain way, and you really have to disrupt this crowd to get something to change. That's one thing. The second is just because ALS has been at it for 30 years or maybe 120 years, I'm not sure, PLS may be a lot more like FSHD. Because facioscapulohumeral dystrophy went from 0 to 100 in less than 10 years in terms of their trial design. So they have a couple advantages. They have a genetic mutation, but some of these patients are very long living, very slowly progressive. They tried a lot of different outcome measures to come down to some that look strongest. They don't yet have a disease-modifying therapy, but there's some really interesting targets. So maybe part of it, what we have to do is look at other related diseases and see what we should bring in. I absolutely think we should be meeting more regularly. I would like to be provocative and say, I don't think I or the patients I have with PLS want to wait until we spend the next 5 years redesigning things. I think they're ready to try things. How we get started may be something we need to push a little bit harder. So next week, other than everyone here going home to a warmer climate, I hope we start thinking about what it really means, what's clinically meaningful to the patients. So those are my thoughts.
Should the next meeting be an actual trial design? I mean, we can actually
Yes, in a warm country.
I liked all the markers and outcomes that were presented, but when we talk about just a pure functional scale, we learned from ALS that when we look at the scale that we're using right now in PLS, the PLSFRS, we're weighting all the categories equivalently, and that may not be the case, and so we have to be careful about it, and maybe we should use some weighted statistical analyses to look at like what's important for the patient while we run these clinical trials.
Yeah.
And I agree with Angela, we don't need to wait per se. We can learn these things as we do clinical trials, whether it's for symptomatic therapy or for disease modifying. And when we do early phase clinical trials, we can look at a bunch of upper motor neuron predominant disorders and collect the wet biomarkers, including the miRNA, which I think is very interesting, neuroimaging, and actually I think we should leverage the CDC that presented today and any other existing natural history studies and piggyback PLS into it.
Michael?
Yes, Jinsi, I just want to add, in the ALS high, all of the individual elements are weighted based on severity and frequency that patients rate. So just to underscore that, I think it's critical. We didn't talk about it.
I think so. We have 2 microphones, so we can talk at the same time. So just to just one.
Okay.
Okay. So maybe natural history study is not a good word. I think we do need to do follow-up studies to validate.
Longitudinal studies.
Longitudinal studies just to validate all these new biomarkers and stuff.
Yeah.
Yeah.
But I'm...
Natural history sounds boring.
Well, natural history can be exciting as
Yeah,
long
but-
as you do something else as well.
Yeah.
So
Okay.
it's what was really nice about what Grace presented, and if you want to go to the physiotherapy literature, there are some standard physio outcome measures that may be very interesting in PLS. The tug, timed up and go, the gait speed. But looking at that, the techniques that Grace presented, and do some more thought-provoking look into what's out there digitally, or just really, it's the opposite of digital. The physios have developed this and have a very strong and large data set as to how to use some of these. So I think we have a combination of totally forward thinking and some traditional things that could build out. But I don't think we have to model PLS trials on ALS trials. I think that would be my biggest challenge to the group. Let's look around.
Yeah. Hande?
Yeah, I have one question to the panel. So I actually learned a lot today, so I'm thankful to all speakers. And especially for drug companies, they don't want to touch PLS because they say, oh, it's like, it takes forever, you have to have very long clinical trials, we don't have the money for it, what is the outcome measure? So, they walk away. But today I learned that for imaging, the significance difference that you can see in 4 months, and the PLSFRS you can see in 6 months. So there can actually be some significant differences in 4 months, 6 months. So these are good outcome measures. So is it rather, and also PLS is a very rare disease, and you may not have pure PLS clinical trial, but is it possible to have basket trials in ALS clinical trials and turn them into basket clinical trials and have PLS as another arm with different outcome measures, with PLSFRS outcome measures, with different imaging, or with different, you know that it is a different disease and different outcome measures. Can we not build basket clinical trials rather than telling PLS patients, oh, we're not ready for you yet? And then from those clinical trials, we may actually learn a lot. So is it not possible?
I think that's what we're really talking about. We're talking about making opportunities. This is about opportunities, because no one was trying anything in FSHD. Myasthenia was considered treatable. Duchenne, they were afraid that the boys couldn't live beyond 18. It's just a matter of things coming together at the right time.
So
and we have to sell it.
I'll just say that in the U.S. we are starting to do that. And so basket trial, just to be clear, basket trial is when you can group different disorders that has the same target. So it could be a biomarker, it could be a clinical outcome measure that's common to all the disorders, and you can group them all together. So that would be your primary endpoint. Your secondary endpoints can be different according to the groups, and the regulators in the US are definitely acceptable of that. However, one of the major limitations is if you're using a clinical outcome measure and they are very distinct disorders, it's very useful in early phase of clinical development, but not so much in late phase clinical development, because whatever outcome you're using has to be something, as we talked about earlier, something the patient feels, or overall function or survival, as FDA would see it. The second point I will make is that when we're doing these early phase clinical trials, it's really important to collect as much data as possible and create these repositories. So being a little more risky, and I'll just say, from the industry setting, so I've had a short stint in industry, using an unusual outcome measure, you can use it, and if you find something that works in that disease area, you can actually, you have a drug response to it, you talk to the regulators, and they may be skeptical, but as you do the clinical development, you want to create consensus around it, and it really is driven by the academic community. So the regulators are not the ones that draw the line. We provide the information for them to draw the line. So if it's important and clinically meaningful, whichever way you want to define it, then you actually get groups who have. We heard about so many people with little data sets here and there. I think we should do a landscape analysis of what's happening and who's got the data, and collect it and publish that first. That's like our next step. And then you would basically publish literature based on that outcome measure. So by the time you're doing your pivotal study, it's an accepted, it doesn't have to be validated, we don't like that word, but it's an accepted endpoint for the regulators. And this is true for EMEA and as well as FDA.
Great. Any burning last question or comment?
Do you think we can convince the pharma to do that? So we may even say that we want to include it as another arm and that we maybe pay for it ourselves or whatever.
We have to show that the patients exist, and that we're going to be effective in recruitment. This is where the foundations will be critical to identify.
Investigate, initiate, part or whatever.
Right.
Okay,
Hiroshi.
Just I'd like to hear in few words, what is the next step?
Next step. Angela, go
So,
first.
the next step tonight is the party at Le Balcon at 7:30, and everyone's invited, and I have to leave in a minute. The second next step is to get ourselves out of our classic approach and look at the things that everyone is presenting and looking at different ways of running these trials. That's my next step.
Okay, the next step for a trial was we should be clear about what is or would be the primary outcome in the trial. It's, because we discuss about many things, but what would be the primary outcome? That's very essential if you want to convince anyone to start a trial. That's the point.
I think there are two next steps. One is to collate the data that we have, the longitudinal data that we have from the various registers, particularly those with survival. So looking at that, the landscape analysis, I like that idea. And then the second thing is to look at some of those interesting biomarkers that were described today. I really like the Serpin one and the microRNA, and try to validate some of those novel wet biomarkers that were described today to us.
I think we could put together a roadmap to therapy, and that could be 4 or 5 steps, which would include the landscape analysis, but then say, well, here's the outcome measure, here's the symptomatic therapy, and then disease modification. So it could actually be a very short type of academic-led approach, but I think that would also galvanize the message.
Yeah, I think, I fully agree with Matthew, because it actually incorporates everything, both validation of outcome measures, and then from that trial design, I think that fits in the roadmap. Good roadmap. I like roadmap.
Maps are good.
Yeah.
I think also knowing who we are, I think we should actually kind of formalize the international consortium of PLS, identify a group of us that are very heavily interested, and then in addition to the roadmap, probably start a consensus-based, just to start off a practice guideline that could help standardize care, and that could lead to the roadmap execution.
This is excellent. I have good news. Everything that you said was recorded. And so, well, so within a month, we are going to share the draft of the paper. So we have a group of 3 people, thank you, Maddie Allen, in the back for taking notes, and we have 2 postdocs who are going to keep taking notes and, write these up so that we can write the roadmap. Any other comments from the audience on the next steps? Yes, Lauren.
I'm just wondering, because maybe I just don't know this, but do we have 10-meter walk-run data or 6-minute walk test? And if not, why did we not do that in this population?
I think 6-minute walk, I think there is a publication on 6-minute. I know we have time to get up, obviously, but I don't, I think 6-minute walk might be published. I don't know about the other end.
So it's a good question. And I think the PLS patients that are sitting in MS clinics as primary progressive MS may have that data. I don't think we're doing it routinely, but that's a good example of where we need to start thinking.
Can I just say the spastic paraplegia rating scale includes a timed walk and a climbed stair count as well.
Fine. So just before we end, thank you to the panelists here. thank everyone who supported this conference. Spastic Paraplegia Foundation, Motor Neuron Disease Association, Mitsubishi Tanabe America, the ALS Association, NILS, and most especially the Marin family and the Campbell family. So.
Actually, thank you so much. Really, thank you so much. Thank you so much. But now you are scary to find the cause of ALS and PLS. Don't stop. Please do. So I'm going to retire at the end of the next March. I don't know what I'm going to do. I'm just asleep. But anyway, so thank you so much, everyone. Really appreciate it. This is really wonderful.